Okay. Sorry, we allow about some few minutes to allow those coming to have them join before we start. That's about maybe 5 minutes or less. Okay. Sorry. Can we hear the sound, the video sound? Is it audible? Someone or some are not giving it right. They can't hear anything. You may mute yourself or you may chat in, just type in the chat box for me when the audio is clear.
That distant and small spot in the cosmos is the habitat of approximately more than 2 million species and the product of billions of years of evolution. Most of this biodiversity is in the soil beneath our feet, but only 1% of soil species have been identified so far. The soil biota constitutes the greatest concentration of biomass of any part of the planet and is composed
Okay, we're about starting now. Okay. To our brothers and sisters of the Muslim faith, we say Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. And to our brothers and sisters of other faith and in humanity, we say good morning, good afternoon, good evening, depending on your time zones. It is yet another day with our renowned Prof. Osman, and to be specific, is a Ghanaian and an agric professor here in Malaysia. Prof. Usman has been sharing with us his expertise since June on a monthly basis. Last month, we ended our series on translating scientific information for scholarly publication. Today, we are zooming into agric in conjunction with the World Soil Day. The World Soil Day is marked every year on 5th December to celebrate the importance of soil as a critical component of the natural system and as a vital contributor to human well-being. This year's campaign for the World Soil Day is Keep Soil Alive, Protect Soil Biodiversity. This aims to raise awareness of the importance of maintaining healthy ecosystems and human well-being by addressing the growing challenges in soil management, fighting soil biodiversity loss, increasing soil awareness, and encouraging governments, organizations, communities, and individuals around the world to commit to proactively improve soil health. With this broad theme, our focus for today is the African youth in smart farming and the development of Africa. It is a topic at the heart of us all, intuitively selected by our dear Prof. Osman to ignite, nourish, reinforce, or revive smart farming ideals in the minds of the African youth for us to see agriculture, especially farming, as a lucrative employment opportunity. Before we delve into the topic, please permit me to provide a brief background of Prof. Usman. For that, allow me to admit those waiting. Okay. Okay, before the introduction, let's have a video on the World Soil Day, what the campaign is all about. Okay, please enjoy for a few minutes.
That distant and small spot in the cosmos is the habitat of approximately more than 2 million species and the product of billions of years of evolution. Most of this biodiversity is in the soil beneath our feet, but only 1% of soil species have been identified so far. The soil biota constitutes the greatest concentration of biomass and the product of billions of years of evolution. Most of this biodiversity is in the soil beneath our feet, but only 1% of soil species have been identified so far. The soil biota constitutes the greatest concentration of biomass of any part of the planet and is composed of an immeasurable amount of mega, macro, meso, and microorganisms. Each of these wonderful creatures plays a key role in the food chain that maintains the fragile balance of life in natural and agroecosystems. If these complex interactions become interrupted, it can cause irreversible impacts for life on Earth, including humans. So, why do we need soil biodiversity? Soils hold many unexpected secrets and perform unseen functions. The discovery of antibiotics has had a major impact on increasing human life expectancy. Soils hold many other potential medicinal functions and possible cures. The natural association between plant roots and microscopic fungi promotes better plant nutrition and growth, tolerance to soil pathogens, and adverse climatic conditions. Through their natural function and metabolism, soil microorganisms are capable of breaking down and denaturing certain toxic compounds and contaminants resulting from many human activities. Part of CO2 emissions into the atmosphere, derived from industry and agriculture, can be absorbed by plants and stored in soils thanks to microbial decomposition that may allow soil carbon retention for long periods of time. This invaluable service provided by soil organisms is key in climate change mitigation. On the other hand, deforestation, monocultures, and the overuse and misuse of agrochemical inputs degrade and reduce soil's health, diminish resistance to pests and pathogens, and cause biodiversity loss that jeopardize the delicate balance that took billions of years to evolve and specialize. We could not only lose a long natural history of specialization, evolution, and adaptation, but also soil's capacity to perform essential ecosystem functions. How can we restore, manage, and conserve something that we do not see directly, and of which we do not have full knowledge? It is our collective responsibility to raise awareness on the importance of soil biodiversity, promote technological innovation to preserve and enhance soil biodiversity, including ecosystem restoration, recognize soil biodiversity as a key provider of ecosystem services and as one of the main nature-based solutions to face all the current global challenges. Invest in gathering better knowledge about the status of soil biodiversity and functions, including by region and land cover type. And develop policies based on scientific evidence to mainstream sustainable soil management and conservation of rich biodiversity soils across landscapes. Everything that we eat and drink passes through the soil biota over and over again. Therefore, we need healthy soils for healthy food, healthy environments, healthy people, and a healthy life. It starts with you. Give a voice to the sound of a living soil. Keep soil alive. Protect soil biodiversity.
Okay, we now move to our introduction briefly. Okay, this is our prof. For those of you who have been searching for his face, this is Prof. You can see his face now.
Professor Dr. Ahmed Osumanu Haruna lectures at University Putra Malaysia, UPM. He was the former head of Science and Technology Research Unit, Institute of Ecosystem Science Borneo, UPM. He was the former head of Science and Technology Research Unit, Institute of Ecosystem Science Borneo, UPM. Professor Osuman is the current head of the Biodiversity Laboratory Borneo, Institute of Ecosystem Science Borneo, UPM, and the coordinator for the Analytical Laboratory at UPM. Bintulu Campus Sarawak, Malaysia. He is also affiliated to a number of research institutes as a research associate. Professor Osman serves as an expert reference for many national and international institutions including NIFA of United States Department of Agriculture, University of Nottingham, Malaysia, University Brunei Darussalam, University of Cape Coast, Malaysian Pepper Board, Malaysia, among others.
Professor Osman served as one of the juries for selecting Best Lecturers in Teaching for UPM's Vice-Chancellor Award for Teaching. Professor Osman is involved in 54 research grant projects and he is leading several research projects at UPM. He had published approximately 355 scholarly work. He had written 18 books, 18 chapters in books, published 222 refereed journal papers, 102 papers in conference proceedings and other publications.
Professor Osman has filed 13 patents and 5 trademarks in Malaysia, United States of America, Europe, Indonesia, and Thailand.
Professor Osman had graduated 49 postdoctoral research fellows and postgraduate students. He is currently supervising 14 postgraduate students. At the international, national, and university levels, his research innovations had won approximately 58 awards. At the international level, Professor Osman had been awarded special award entitled Most Promising Innovation. Furthermore, in February 2020, he received International Award of Merit from the Republic of Croatia. In 2019, he was awarded the Most Productive Book Writer at UPM. Since 2007 to date, Professor Osman is on UPM Excellent Service Award. Since 2007 to date, Professor Osman is on UPM Excellent Service Award. In recognition of his contribution to UPM, he had been awarded UPM's Vice-Chancellor Award as Best Young Lecturer in Teaching and Gold Medal for being Best Lecturer in Teaching.
He has also been invited as a prominent speaker in many national and international scholarly or intellectual forums and meetings.
Currently, Professor Osman is on several of advisory boards. He continues to render public services and consultancies to many organizations.
For example, Professor Osman is an expert reference for People for Peat, a coalition that comprises of the World Resources Institute Indonesia, Tropical Rainforest Conservation and Research Center Malaysia, and the Sustainable Trade Initiative Indonesia, represents Component 2 of the EU-funded Sustainable Use of Peatland and Haze Mitigation in ASEAN project.
We thank you, Professor, for this sharing of your expensive thoughts with us for free. May I now call on our renowned Agric Professor to the floor. Welcome, Professor. The digital space is yours.
Okay, thank you, Prof.
Assalamu alaikum and good day to everyone, and hello to everyone. Thank you very much, Dr. Mutaka, for the kind introduction. And I would also like to thank the organizers for all this important meeting. I wouldn't go much into the details. Perhaps we will go when we start. And may I know whether I'm audible?
Yes, we can hear you, Prof.
Right. As you have already introduced the subject, I think all this kind of information that was provided through the introduction was not by myself alone. These are some of the members of our group. So I think they also have contributed immensely. So we would also like to acknowledge them. I never did anything in vacuum. So these are some of the personalities that I could recall. Now, I will go straight to the topic. And what I'm going to do here is I will start a little bit of water and food. I will start from the global scenario, then narrow it down to Africa. So that's what we are going to do, during this session. Now, if we just look at what they call the distribution of rainfall or water across the world, here we see that from 2000 and 2009, we began to realize that we are having some sort of water shortage. And later we will know that water shortage can be in two forms: scarcity, based on physical and economical. So here, what we can see here is we are having a problem with water that is continually diminishing. And it is predicted based on different scenarios that by 2069, we're going to face a lot of water shortage. And this is going to be a little bit a serious issue. And as you can see, none of the, continents are really spared. None at all is spared. So it's something that we have to be very, very serious about. And as the focus is on Africa, you can see the red areas are showing us that we are losing a lot of water, and that is not unique to Africa alone. Now, let me bring you down to what we mean by, a water shortage. If we look at the what do you call it, this world map, we realize that by 2025, 2 billion people will have absolute water scarcity. That means that will be a physical barrier. And those that are going to face this kind of situation, you can see that Africa is no exception. We are talking about a little bit of Europe, also talking about a little bit of, let's say, like Asia. And something that is very worrying is that we are also going to see a situation where we're going to also face economic, water crisis. And this is going to be about 2.7 billion. They have to develop their own water sources. And that is, you can see in Africa, a very significant portion of Africa and Latin America are going to suffer. And so will be what we call Australia and a little bit of Asia. Right. Now, of course, in other parts of the world, they might not have much of water problem, but it is eating into that area. Unless you are in the polar areas, then water has not been a problem. Now, based on this, we also want to look into the specifics. If we are talking about the specifics, where I have just highlighted are the ones that are facing economic, water shortage. And then we have Africa. So you can see here we are confronted with two situations: physical barrier and then economic barrier. So that is what is going to happen. Now, that being the case, I think we need to understand when we say physical water scarcity, what do we really mean? What we mean is like this: water is not in any form. The availability of the water is not in any form. That means that without the water, a lot will perish, crops and whatever. So that is what we mean by physical water, scarcity. Now, and those are the red zones that I just showed. So let me just use this example. You see, this is a very beautiful area. Water is everywhere. So if the water should, just diminish, and then we see the bare land and we are not even find any space to get water, then that is what we call physical water scarcity. Now, when we go to what we call economic water scarcity, what we mean is the water is present, but it could be due to certain lack of, let's say, technology or pollution or whatever. So if we don't have the technology to prevent the pollution or improve upon the water quality, then it's going to be a problem. It's just like you have the seawater. It's water, but we can't drink it if we don't process it. So because of this, especially this is what is going to cause the problem: human resource, financial resource, and of course, institutional resource. But the most striking one will be what we call good technology. As we know, Singapore is noted for trying to get water from the sea. So here, if we don't have the technology, then it becomes a little bit of economic barrier, right? Now, this is an example. So a classical example here would just be like our own lack of, sense of aliveness, that we don't look into the water system, and then we keep, polluting water. Then that is going to be a problem. And when we go down to agriculture and other types of activities, this is what we call algae bloom here. So that means that you have a lot of algae growing in the water body. Sometimes it could be due to excessive fertilization, like when you apply too much of nitrogen and phosphorus, and it could be due to other things. So these are real things that are happening. So this is a classical example of the looming effect of economic water, scarcity. Now, in the face of all these challenges, I just want to draw your mind to what we call a food pyramid. This is nothing new, but I just want to relate it to the kind of waste that we are generating. By right, this should be the conventional food pyramid, although it has been modified a bit. And as we can see here, the basis of it is more of carbohydrate. Then we go to vegetables and fruits. Then you go to what we call it, source of protein, and then a little bit of fat. So this is exactly when you take a balanced food in the world, this is what we should expect. But what is going on now is, you see, I mean, we are becoming a little bit, excuse my word, irresponsible in the way that our waste is just too much. So here, instead of us to build food pyramid, we are building waste pyramid. And later on, you will see how we're going to also use this waste to also manage the soil. So that is the situation. By right, we are supposed to be this side, where we are managing our system very well and we build the food pyramid. But rather, what is happening now, we are building the what? The waste pyramid. And all this will come from our own. And if we were to accumulate this waste, it could be, I mean, we can use the way to feed almost 1 billion people. And the irony is that every day, 1 billion people go to bed without food. And then look at what we are doing. So this is something that we have to take seriously. It doesn't end there. If we go down to what we call the greenhouse effect, if we were to accumulate our food waste, I'm talking about only food waste, please, not any other waste. So here, if we were to collect and then we try to compare in terms of greenhouse effect, that means that we will have, example, the food waste to be the third country that will be emitting a lot of greenhouse gases, one of them being carbon dioxide. So the first from China to US, then the food that we are generating is also part of what we call the greenhouse effect in terms of only carbon dioxide. Now, if we also go a little bit detail and you want to quantify the amount that every year we waste is about 1.2 billion tons of food. And it will represent 1/3 of the global food production. That is very, very significant. And if we turn it into financial, or if we capitalize it, or we translate into financial terms, we have almost 750 billion per year that will go waste. And when we go into, let's say, greenhouse effect, is almost 3,300 trillion carbon dioxide being emitted. And in terms of water, 250 kilometers per square. So here, that is quite alarming. And what is really, really baffling is that we are talking about cereals and vegetables. Almost 2/3 of the waste will come from cereals and vegetables. So I think we all have to educate ourselves, but at least you just eat what you can eat and we stop producing what we don't want to eat. I think that will be the best solution so far. So we are all responsible. Now, let me magnify the situation for you to see what we are really facing. Let's go to the F and look at the land and relate it to agriculture, because not every land is good, and now we are talking about soil. So here, if we are all familiar that if we take the surface of the earth, almost 71% of the earth will be made up of oceans. Now, that means that we have only 29% land. And if we look at it, even the land, we are also having almost 30% of the land is not habitable. Some could be for glaciers. We are talking about barren lands that are not useful for agriculture. We just have to leave them like that. So now, with this 71%, what are we seeing? Agriculture can only take 50%, and the rest will be forests, shrubs, and others. So you see, the land is very limited. I'm talking about land. I haven't come to soil yet. So with this 50%, let us assume we can even, it's an arable land. Let us assume. That means that if you look at livestock alone, it's taking almost 77%, and only 23% will be for crops. And we know when we look at the food pyramid, the basis of food should come from what? Plants. And where would the plants grow? Definitely on soil, the bulk of it. So let's see. Now, when we translate this into food calorie, then we also see that it is the plant that will give us what? The bulk of our food calorie. And here, what we are talking about with the livestock is taking a very big area, a huge area, but it's contributing only 17%. Right. So then we come down. So if you look at the pyramid again, you can see we have just a little land to do some, the work, and the animal side will take a lot. And later on, you will see why I'm stressing on this. Now, when it comes to proteins, again, we have no choice but to fall on the plants. Actually, we might think that the livestock industry is the one that will give us a lot of what we call proteins, but actually it's through the crops. So that is another disturbing thing vis-a-vis soil degradation. Now, why did I stress on this? I'm stressing on this because if you look at, even if we take agriculture and we are talking about the greenhouse gas effect, we will see that we will realize that at least the bulk of the greenhouse gases in terms of, let's say, example, carbon dioxide will come from the animal source. And definitely we understand why it is like this. Now, even if you take urea only, it can come a lot from the animals. So here, again, we are taking much of land for the livestock, and then the crop is getting little. And in terms of pollution, the crop is emitting less compared with the livestock. Now, with all this background, let me bring you back again to the waste. So here, I'm talking about post-harvest loss. I'm talking about post-harvest, the waste that we try to work on. And let's see how serious it is. You can see everywhere you go on any part of the world, this is what we see. And this is really, really not very good when I relate it to soil in particular. Now, when we look at this, let us assume we want to really share this kind of waste that we are producing and then translate it into money. That means that every week, each and every one of us we are spending $28 just on waste. And if you look at it, 40% of our food will just go, we throw them away, when in reality, we could have actually used them. And the last part will be the leftovers. And the leftovers are just there. It's not that they are spoiled or whatever. It's just that we are a little bit not working out well. Right. Now, this will now bring us to what we call food security. Now, remember, I have moved you from water, slowly coming down to what we call the seriousness of the little soil that we have in terms of land. And then here we are also talking about waste. So let us look at the threat on this. But before I do this, we will have to understand what is food security. Really, food security does not mean that the quantity of the food that we have. It doesn't mean at all. That is not what we are trying to drive at. So what we mean that any human being anywhere on the surface of the earth should not be limited by any physical, social, and economic barriers in a way that such person is not able to get sufficient food and the food is not safe, talk less of being nutritious. And the other part is when you take that food, it should provide you with your dietary needs. And you should have the liberty to choose what kind of food you want to eat so that your life will be active and then healthy. So anything less than this kind of definition, no matter what you have it, it is not considered as what? Food security. So now let me break it down. The definition actually is talking about just 4 components. What are the components? Availability. We are also talking about accessibility, utilization, and stability. That means sustainability. Now, for us to understand this part, we will have to understand why we are interested in food security in relation to stability. We may produce, we may have more food, we can access it, we can use it, but what if we have shortage of food? This is where stability is very important, and this is why the topic is very relevant. It's topical because without modern technologies and try to move around vis-a-vis the ever-growing population of the human family, then we are in trouble when we don't have stability in terms of what we call sustainability. This is why you see that the driving force for us to have a nutritional outcome of our food, in agriculture, will be what? Will be anchored in what we call stability. So now, what do I mean? This is an example. You see, this is what we call soil degradation. This is gully erosion, starting from rill to gully. This is very serious. So here, if we look at it closely, if we are in this kind of environment and we try to produce, and now we are being challenged by erosion runoff, then whatever we are producing will not be sustainable and the stability will be in question mark. And this is a classical example in Tanzania. With all due respect, I'm just trying to give you examples. Right. Now, let me go a little bit detail. So when we talk about food utilization, we are talking about the nutritional value, the social acceptance, the taboos involved. If there are certain kind of food too much taboo and they have very good, economic values and nutritive values, then it is not considered as food security. Of course, the safety, is the food polluted or whatever? Accessibility here, can we really afford? We have a number of, the human family who cannot afford 3 square meals. That could be a very, very unfortunate situation. Allocation, how do we allocate? Even if you have the food, do I have the, the privilege? Do I have the liberty to choose what kind of food I want to take? Now, when we come to availability, we are talking about production in terms of quantity. Can we distribute? Can we even export? Or can we import from other parts of the world if we are deficient? So that is what food security is about. So to summarize it all, we have what you call the 5 A's of food security. They are answering this kind of question. Availability, is there enough food? When you talk about accessibility, here we are talking about, can we get the food and can we afford it? Acceptability, like I just said, the food and then the system of delivery, are they culturally accepted and appropriate? And the adequacy, the amount, how safe is it, how nutritious is it, and how sustainable is it? At the end of the day, if any one of these 4 A's, one is missing, then we need to take some we have to put in some interventions. And those are the things that I'm going to talk about very soon. Now, why did I take my time to stress on food security? Some of you might wonder that this is not relevant, but it is really relevant because we need to understand that with the ever-growing human population, we will continue to need food. And where do you get your food? These are the issues. We have no choice but to go to the soil, even though we have other technologies that I'm going to share with you, but the principal source will be what we call the soil. Right, and this is it. We are saying that by 2023, we're going to have, the human population will be 7.7 billion. And that is quite serious. Sorry, by 2023, it should be 8 billion. Now we are hitting around 7 billion. And if you look at what do you call it, the history of the human population, we can see a an exponential growth. If it's not just like a linear, we can see those in the developed world, what do you call it, the population is getting is getting stagnant. So this stagnation is being offset by we in the developing countries. So the blue color represent the developed world, and then the green represent the what? The developing world. And you can see that we are the source of the projection in the human population. Very, very, what do we call it, significant. So here, the question now is, if we don't move away from the traditional way of doing agriculture, then we will bear the brunt a lot. So these are the realities that we are going to face. And definitely when you have the population boom, there will be pressure on the soil, and there will be pressure on water and others. So these are the realities of life. And definitely you heard about the, what do you call it, the soil, the biodiversity. And that is what is going to happen. Without the soil biodiversity, we can't do much, right? So it doesn't end there. We will also have to survive based on the kind of food we want to eat. So I'm just giving you a very classical example. This is what we call cocoyam. Sometimes we also have what we call water taro. Now, this is very common in West Africa and other parts of the world like India and the rest. Now, what I do know is this kind of cocoyam or whatever, we take them a lot. And it's not only the tuber, we also take the leaves. And we do know that the leaves are very, very, very what? Healthy. And that being the case, assuming my understanding is when I check from maybe my sources, I'm made to understand that most of these, this, what we call it, cocoyam, is almost on what? Extinction. And that could be a very, very unfortunate situation, because if you look at cocoyam, and especially the leaves, it contains almost 22 nutritional, what do you call it, functions. So you can imagine the kind of health status issues that we are going to lose. So these are the realities. Now, those of you who are not familiar, this is cocoyam that has been boiled with some sauce and then plus whatever. So in Africa, in certain part of West Africa, This is very common. And sometimes also we prepare. You see the green thing. These are the leaves of cocoyam, and they are very, very what you call it rich. So here we take this sauce with what you call rice. And in other parts also we will use them with what? You are talking about avocado plus what we call, these are all what we call this, the cocoyam leaf that have been transformed into a sauce, plus what we call plantain. This is a very, very important dish in Ghana, Nigeria, and maybe other parts of West Africa. Right, so we are going to lose these things if we really, really don't sit up. And I'm going to hit more on that later. Of course, I have already talked about water. Our survival also depends on water. So let me put it in another way. So if we were to quantify, 1.8 billion people are already facing water scarcity. Now, if I go a little bit deeper, this is what we're going to see. Almost every year, we are getting to 1 billion people suffering from diarrhea. That should tell you how unsafe the water is. And out of the 7.7 billion, we are having 5.2 billion who are guaranteed with water for the time being. But the rest are also being challenged in terms of water contamination. It could be due to heavy metals, arsenic, or whatever. And one thing that is very, very serious could be lead. Lead contamination is becoming serious, almost 21 million in USA only. I mean, sorry, in the northern and southern part of America. And when you go down, if let's say in America, 1 in 4 are going to have unsafe water drink, then you can imagine what is going to happen in the rest of the world. So these are the realities of life that we all have to ponder over. Right. Now, giving you this background, this is who will be suffering most. Definitely when disasters strike, the children, the women, and the old. So these are the things that are going on. You can imagine who is going to survive under this situation. Right. Now, again, with this population issue, let us now go deep into the soil. You can see here on the global scale, no one is safe now. If we can see, the red color is telling us that the soils are highly degraded. That means that we have to leave them and then maybe let them rejuvenate through rehabilitation or whatever. That can be very, very expensive. And if we also look at other side, we can also see that even in Australia, they also will have their own degraded soil, Africa, almost everywhere in the world. Now, then what we are talking about is stable soil. Stable soil are the ones that maybe could be cultivated. And we can see those that are stable, actually they are in the what? They are in the, what you call it, the cold areas. So they are stable because maybe it's not all that easy to cultivate. That means that we are really, really in a situation where we are not taking good care of the soil. So these are the realities. Now, if I bring you down to Africa, you just look at it, getting to the arid, I mean the semi-arid, getting to the arid area, you can see clearly that that soil has no vegetation. So without this vegetation, what are we going to do? This is why desertification is eating almost every day if we try to quantify. So these are the realities that I think we will really have to ponder. And this is why we are trying to target the youth. And this is what is going on now. You can imagine what is going to happen to this plant. Right. Now, it is believed that if we continue with the way that we abuse the soil, now maybe the next world war will be scrambling for soil. And as you can see, this is what you call the shifting soils. The shifting soils by 2021 is going to be very serious. So what we see here, all these soils that you see that I've highlighted, these are areas that are no longer farmable, or we have to mitigate with a certain sophisticated kind of devices. So if we are talking about we don't have much soil, the green color is telling you these are the arable lands. So if these are the arable lands, that means that we have just little. So it's going to be like the survival of the fittest if we don't reverse situation. And I think FAO is very serious about it. This is why last year the whole team was on soil erosion. So these are some of the things that I can share with you. Now, coming down to temperature, we can see the global warming. When you look at the scenarios with the predictions, we are seeing that the global warming is getting on, and it is real. Right. Now, why am I interested in this, or our team is interested in this, is the fact that most of us are thinking that when we say the environment is going to be hot or heaty, we are talking about the water bodies or the oceans or the atmosphere, but in reality, the consequences will be on the soil. The land is going to get very, very warm, 5 times what we think about the ocean. So you can imagine what is going to happen to us. Now, let me give you a very simple example. If, let's say, we have the world temperature, atmospheric temperature, or whatever, to increase between 2 to 2.5 degrees Celsius, we should expect that the soil temperature will increase by 10 degrees. So that means that you can see how this serious is it going to be. This is why this year you see that we are talking about soil biodiversity. You remember the biodiversity is sensitive to temperature. So this is really, really scary. Now, if we break it down, then we will have to look at the global temperature in terms of soil and water. And unfortunately, if we don't reverse the situation, what is going to happen in agriculture and food production will be the what? The number one culprit. So this is these are some of the things. Now, what is the way forward? Perhaps we will have to go back to our own self-discipline. There is no way. It's just like COVID-19. If you don't discipline ourselves, we just put others in trouble to get out ourselves. So here we might need collective discipline. So all this education that is going on, I think we need to take it seriously, because no one, even the medical doctor, can never treat you if there is no food. So these are some of the things that we have to look into. Therefore, we don't have a choice, but we have to have some adjustment in the way that we do things. So we must adjust for positive outcome and not negative outcome. This is where we need to balance. We need to find out what are our needs. So our needs should overweigh our wants. So we don't want this situation where our wants will be what? Affecting our needs. We should have to champion it, and we need to reverse it. Especially those countries that are well endowed with natural resources, and through the natural resources, we've been degrading the soil. We will pay for it if we are not disciplined. Therefore, the issue is now and not tomorrow and never. So if we look at it clearly, then in things that maybe in terms of what in urgency and importance, I think we must do it now. We don't want to do it later. We don't want to avoid it, and we don't want to delegate it. So those are the things. Now, slowly, I'm going down to the soil. I'm not going to sound technical, because if I were to talk about soil, it would take me one whole semester. So let me just talk about this. Basically, if we talk about soil, it's a natural system. Nobody actually creates a soil. Of course, we have our own beliefs that God created soil. I'm talking about scientific issue now. Let us keep our beliefs somewhere else. So here is a natural body, we all know. And it's dynamic. The soil is very, very dynamic. That's why we talk about soil resilience. It is one of the most versatile, resource on the earth. That this is why we keep, abusing this kind of soil. So here, if we look at it, it contains what? Minerals, organic materials, and even living organisms. It could be plant, it can be animals, it can be whatever. So they all come together to develop the soil, and then from there we can grow, develop, and then reproduce our crops. There's a basic definition, there's a technical definition, but here, for this to happen, we need climatic information, principally precipitation, and then what we call it, temperature. Of course, topography, microorganisms, and time, all of them come together to form a soil. So the biodiversity issue that we are discussing will fall under organisms. Now, therefore, from here, we can see that in the whole world, we have 12 orders. 12 major groups of soils, and depending on where you are, you will see where this kind of soil. I'm sorry, I wouldn't have time to tell you each one of them, but I will zoom it to Africa, and then we will see. Now, when you look at Africa, almost the 12 orders of the soil that we have in the world, we have about, I think, around 10 or whatever, because it doesn't snow in Africa. We don't have what you call the polar regions to have what you call jelly soils or whatever. And let's say like a soil like Andy soil is from volcanic eruption. We have very little volcanic eruption, so we don't get much of this kind of soil, but we have them. So that means that in terms of soil, we don't have that kind of problem. But what is challenging us now also is the soil pH. And again, if you look at Africa and the rest of the world, we have the soil that are acidic, some are neutral, and some are alkaline or saline. So these are the things, because this ecological zone will tell us how much we manage the soil and then what kind of crops we are going to, crop. But something very, very interesting is this. Maybe I'm not sure if most of you are aware. Now we all know that we have 17, what you call it, the Sustainable Development Goals. And it will surprise you to know that almost, more than 90% of it, 80% of it comes to soil. So they all relate to soil. So out of the 17 Sustainable Development Goals, 12 of them are directly or indirectly related to agriculture, and in soil particular. To be very, very specific, these 12 are related to soil. So you can see the importance of soil in the economy of the world. Now, even if I want to be conservative and be very, 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 very specific, we can count minimum of 8. How do you how do you eradicate poverty without agriculture? How do you get, productive agriculture without soil? How do you, get hunger out? So you see, these are the reality. But how many of us really have thought about the role of soil? How many of us? We just look at it, it's just there, and then we abuse it. Now, let me give you some very, very serious statistics or information, the basic facts about soil. If we look at the soil, one, there can be no life without soil, whether we like it or not, within the human capacity. That's number one. We need the soil like the air that we breathe, whether we like it or not. So much as you cherish the air, it is incumbent on us to also cherish the soil. Right. Now, the other aspect will be, like I just said, 10% of the land that we have, the soil is what? Not even up to 10% of the land. That means that is quite little. And the most important thing that maybe I want to derive at will be that it takes not less than 500 years for us to form only 2 centimeters of a topsoil. 500 years. Now, if we are talking about that, I'm relating it to what we call fertile soil. Topsoil, not every topsoil is fertile. So here, when I say a fertile soil, it is going to take us almost 2,000 years to form only 10 cm. And it takes us just few minutes or few days to just destroy the soil. Now, if we also go very deep, then we will see that in most cases, if you deplete the soil or destroy the soil, no matter what you do, it is gone forever. Because soil is what we call a non-renewable resource. No matter what afforestation or whatever, we will never come back to the original state. Even if you want to come back, then you and I don't think that we will be living, we will be alive to see that. Now, because soil relates to plant and then forest, then we can say that the moment that you degrade the forest or the plant, being it through mining, irresponsible mining, or being it whatever, then this is what is going to happen to the soil. Now, if we quantify how much of soil we are losing every year, we lose almost 30 million hectares of forest. The moment you cut 30 million forest area, you can imagine how much of soil you are losing. Now, once we cut also the forest, we don't do very good what you call forest replanting. So if we don't do that, then that is aggravating the whole situation. I give you an example. Let's say we cut the forest and we go for monoculture, especially around the slopes. Then it means that we are going to aggravate what we call runoff, leaching, and erosion. So these are some of the things that are causing us a lot, but we are taking it for granted. Now, and in terms of even, let's say we go to the highlands, we have cleared the area, we don't even protect the surface of the soil. Later on, I'm moving you to what we call conservation agriculture. So if they are left unprotected, then we are accelerating what we call soil erosion. And this is the issue now. If we go back down to quantify, let's say, example, I'm just giving an example. In 2011, we were all shocked that we have 2 billion tons of fertile soil that were lost only in 2011. So now you do the math until today, and you can imagine if we have not changed or adjust our situation positively, you can imagine what we are going through now. Now, if we were to quantify it based on each individual, whether you were born today or you are even 90 years, and we are taking the share, 3.4 tons per each person. So you can imagine, multiply by 7.7 billion people on the surface of the earth. Again, translate the soil that had been eroded into money. That means that every year you are costing $70 in terms of the soil that we are eroding. And then what will be the total? Now the total goes down to almost 490 billion that we every year in terms of soil. I'm not exaggerating. These are bare facts that we cannot deny. Right. Now, the key thing is, please remember that the soil is not renewable. Contrary to what we think, the soil is not renewable. Now, all these losses that we've been talking about, let me relate it to biodiversity now. If we were to take a cup of soil, it has more organisms than the human population. Just take a cup of soil and then put look at the organisms within the soil. It will be more than 7.7 billion human beings that we see. So you can imagine if we are losing almost 2.4 billion tons of soil per year. Now, if we move down, we can also see that whether we like it or not, I'm going to show you other type of technology that we use in agriculture, but the soil is the number one source of our food needs. So again, what is happening? Erosion and pollution is the cause of our own problems. This is an example. So you can imagine you are in this kind of area and this is what we have. This is another example. This is also what we call soil degradation. And then we have another example on this. So if you are in your area and you feel that because you are far from the forest, it will follow you until where you are. So let us be a little bit careful and a bit serious here. Now, if we are talking about conversion of land into towns and cities, that is another shocking thing. Every year in Europe, a land size of Berlin is converted into a city or a town. So you just do the mathematics for the other parts of the world. If we come down now, by 2050, all our arable land, the map that I show you, if we don't change the way we do things, we are going to halve it. So you can imagine if we get 2100, what is going to happen if we continue with this habit. And here, like I just said, if now 1 billion people in the world go to birth without food, and then we are destroying the soil, or we don't just care, we don't have institutional policies to really take good care of the soil and taking it for granted, then we are all in the boat. And this means that what we need to do now, apart from advising or taking a disciplinary approach, that means that we have to what we call use small land and produce a lot. Because otherwise we cannot continue to be opening the forest and whatever. That will never be sustainable. This is where smart farming is coming in. Right. Unless you want to tell me that we are going to discover another planet and we move to that place. Until now, we are not very sure. So let us preserve what we have. That means that we will have to have policy makers. We have to draw the attention to be really serious about this. Unfortunately, although we are having soil that is not, it's fine, and that means that it is going to get depleted, we still don't have that kind of institutional will to do this kind of policies that we will need. Can you imagine? Can you just imagine that we will have to have a, what do you call it? We are going to do construction somewhere, or we are going to develop an area. And all that we know is we only have to invite civil engineers, mechanical engineers, no soil scientists or geologists is invited. So these are the realities of life that we are facing now. Now, summarize it all. let me bring it down to an ordinary level for you to appreciate it. If we were to take our time and we look at this, what we call it, a picture, what I'm trying to show you is, being it a plant, being it a human being, we all need what we call it, about 18 elements that we need to keep us healthy and keep us going. Now, if you look at the human and then the plant, you can see that most of these nutrients that we need will come from the soil. Only hydrogen, carbon, and oxygen will be abundant in the atmosphere. So now, this is why we have to have a healthy soil. If we don't have a healthy soil and we keep degrading it, what is going to happen is we are consistently going to lose our micro and macronutrients. And once the soil is poor in micronutrients, we are going to have a lot of deficiencies, copper, zinc, and whatever. So here it is estimated that 2 billion people are having problem with micronutrient deficiency. So not until we have a sustainable soil management so that the soil will be healthy and we produce healthy food, forget it, we will ever remain having problems with our health. So this is why we need to increase the soil organic carbon by doing what we call natural farming, biological farming. I'm going to talk about them. We should also avoid using too much of bulldozers and whatever to bulldoze our soil. So we should do what we call minimum tillage. I'll show you this, and keep the soil surface cover, at least plow or maybe work on only the area that you are interested, so that we can reduce soil erosion and we can maximize our crop output. Now, let us bring it to human terms, and then we see. Okay, we will see here, if we look at this side, we will see that this is the layer of a human skin. If we take a little bit of the human skin, we can see the layers. Now, as you can see, the layer of the human skin, the skin is equivalent to the layer of the soil. This is what we call the soil profile. And the layers that you see is called the soil horizon. Most of you are familiar with topsoil. So topsoil is equivalent to this side. So if we equate the human skin in terms of properties and the soil, this is how it is. If you can spend a lot of money taking care of your skin, and we have an equivalent that is giving you food and we don't care about it, then I think we are getting somewhere that will not be really, really acceptable. Now, it doesn't end there. Just take the human colon. We all know that the human colon is a very important organ, because once there is cancer in human colon, then that's it. So here, if we even look at the human colon and we try to equate it to what do you call it? Vis-a-vis the what do you call the soil profile, we can also see the layers. And the last part, the other part will be the human duodenum. Between the small and then the large intestine, we have what you call the duodenum. So here we can see also, when we look at the layers, they are consistent with the layers of the soil. So let us be responsible here and then look at it like we are dealing with our own human beings. I'm a little bit passionate about this because where we are heading is quite scary, right? Therefore, if I go back to the soil, how are they formed? Generally, two major soils. One group of soil is formed from minerals and rock, and the other one from organic materials. So when we talk about the mineral and organic, if I take the mineral soil, I'm not going into details. All that I want you to understand that the minerals that we are talking about, you are all familiar. We are talking about igneous rock, sedimentary rock, and then metamorphic rock. So depending on the type of rock that we have and the mineral, that will tell us the characteristics of the soil and how we manage. So these kind of rock that form a soil, that is what we call the mineral soils. And again, they will also be controlled by climate, topography, microorganisms, and then time. And just like human beings also, we have what we call young soil, middle-aged soil, and old soils, mature soils. So each group of this kind of level will take time, and then we need different management approach. So those of you who are interested in agriculture, you don't just buy any land anyhow. We have to understand what you call it, the soil properties in terms of age and then the quality, right? So this is what I'm saying. Later on, I will show you, even if you could master the soil color, if you could master the soil color, you can do a lot. So these are some of the things. So when you see these kind of colors, they tell us a lot. If, for example, this gray color is telling me this is a very waterlogged area, and you need to have a drainage system. Otherwise, you're going to have a lot of problems. I'm going to go through the colors very soon. So this is a classical example of a mineral soil. Now, if you talk about organic soils, these are organic that are formed from plant human decomposition, and then we end up forming a soil. So here, that's why you see generally they are dark in nature, because they are full of carbon, hydrogen, and oxygen. So these are the kind of soils. They also have their own challenges. And sometimes you have the soil, underneath it, you have the mineral soil. So you see this layer is a mineral soil coming from rocks, and these soil are very acidic. On top also is very acidic. So if you want to really handle this kind of soils, you have to know the properties very well. It is not straightforward like we think. Otherwise, you are in for bad investment, right? Now, having brought you down to this, let us now zoom to Africa. Now we are more into Africa now. Now, for those of you, I understand there are international participants, and then we thank you for coming or whatever. But what I want to show is like this. This is the strategic location of Africa. Africa is almost in the central part of the world, the center of the world. So those of you who are not familiar, this is Africa. Now, I mean, a little bit of education here. I just want to make it clear that Africa is not one country. It's very amazing that a number of people think that Africa is just one country with different tribes. Africa is not like that. It's made up of almost 54 countries, sovereign countries. And just like any part of the world, we also have our regions. So you can see in the blue is the West Africa. You are talking about North Africa. We have the Central, we have the East, we have the South, and whatever. So this is the nature of the African distribution, right? Now, just like any other parts of the world, we are all blessed with resources. And you will be surprised to know that one of the most richest continents on the earth is Africa. Now, let us see. If we go down here, why am I saying this? It is the only country on the surface of the universe where almost every country has a natural resource, and not just any ordinary natural resource. So this is the situation that we find ourselves in. We are blessed with so many things, and before the world, we are just nothing. Excuse me to use the word. So we have to ask ourselves, this is what motivated some of us to say that we have the resources, we are not making it like our potential will allow us. Therefore, why can't we also veer into agriculture and see and take it seriously vis-a-vis what we call, technological breakthroughs? So here, if we look at it, break it down, go down and talk about ecological zones. Africa is not behind. You talk about desert, we have. If you talk about climate in terms of rainforest, savanna, Mediterranean, the steppe, we have them. So it's like everything that is the world is also in Africa. So why is it so? Of course, there are other things we can't go into, but when it comes to moisture, just like the rest of the world, they are also having challenges of moisture, but that does not deter us. So these are some of the things. Now, all the moisture regimes, those of you who know the moisture regimes, we have xeric, oustic, udic, perudic. So these are some of the moisture regimes that you need to understand for, a very important type of agricultural setup. And we can see clearly they are also there. Now, but what is going to happen is if we don't take this agricultural system very carefully and go into what we call conservation agriculture, those of us from Africa, we all know the role of the Nile River. And it is predicted that if the Nile River, there should be increase in 4 degrees around the Nile River. That means that we are going to have a sharp decrease. And then if there is rainfall decrease of 20%, then the Nile River will dry by 90%. So you can imagine this Nile River is being driven by a number of countries, Egypt, Sudan, you are talking about Ethiopia and the like. So these are the things. Now, this is why we need to dive into the state-of-the-art technology and try to be smart, not only in terms of technology. So therefore, when we talk about climate smart, of course, we are also talking about grow a plant or crops or whatever, but for how long? This is where we don't have a choice. We also have to embrace technology. If a continent is blessed with resources, don't tell us that we don't have the capacity. The human resources there. The physical resources are also there. So we also have to participate actively in the context of technological breakthroughs. Therefore, we may need census. And don't tell me we are going to be the consumers of what we call technology. We must be part of the producers. Because once you have the technology and you are going to agriculture, you'll be able to collect your data, and then we will be able to customize the data, and the data will help us to predict if we have some sort of climatic scenarios or pest infestation or whatever, or even bushfires or whatever. We should be able to do that. We should be able to use it to predict desertification and how we mitigate the desertification. And from there, we should be able to pinpoint to the farmers the signals. What are the inputs? When would they add fertilizers? When would they water? When would they avoid adding pesticides? So these are all hinged on what we call technology. So there is where the technology is becoming so common that you can even use your handphones to monitor what is going on your field. So don't tell me we have countries like Nigeria, we have Ghana, we have, Rwanda, South Africa, Tanzania. Count them. The people are there to do all these kind of things. There is where we might need smart farming for planning, controlling, and monitoring. So this is the buzzword. We are talking about Internet of Things. But I'm not going to hint too much on farming. Smart farming also means the way that we use our intellect to turn around. Right. So here, if we are talking about that, for us to be climate smart, we can still predict this kind of a traditional kind of agriculture, just that we need to put it in another scale. So you see, integrated farming, crop and animal will ever exist. Whether we like it or not, agroforestry will be there, intercropping will be there, crop rotation, cover cropping. So what we need to do here will be that we just have to step up the game and enhance the system. And how do we do that? We will discuss very soon. Now, in terms of soil quality, if we really don't step up the game, in terms of soil quality, we will be a little bit handicapped, because in soil quality, we look at two things: soil resilience and then soil, what we call it, performance. And you can see the soil resilience is moving towards what we call, this red colors are showing that the soil is not resilient. If the soil is resilient and the performance is good, it must be green. So you can see that we are having just little amount. So this is where organic, farming and whatever should come in. And then we also have to tailor, we have to look region by region and see what are the capabilities, what kind of agriculture should we practice, and what are the kind of technologies that we need to deploy. So these are some of the things that we need to look into seriously. I give you a classical example here where we are talking about cereals. You can see that even if you look at across West Africa, Ghana, and the rest, you can see that the cereal production, if we don't change the way we do things, only a few parts of the African continent is doing what we call is going to increase in cereals and whatever. So you look at the green part, these are the areas that are going to increase, and the rest that are even going for what you call a depression of cereals. So this is where we need the technology, we need the brains, not only gadgets, but the brains, and then of course institutional policies must be strong, and it must be government will must be there. The other aspect that I think we need to be very, very wary of, and we need the youth to get into, will be diseases. If you look at EMI World, almost 90% of the continent, in 2018 had problem with EMI World. Now, what you see here, that time was not confirmed. So we are talking about the Arab regions. We are talking about the North Africa, or only maybe spared because maybe like the temperate area, whatever. So these are the challenges. And how do you deal with this when we really don't understand smart farming, we don't have the technology, or we are refusing to embrace the technology? This kind of co and cutlass kind of agriculture will never send us either we take it or we leave it. So here, one thing that we will have to capitalize on, and if we don't capitalize on it, will be a big disaster for us, will be the population that Africa has. If you look at the population density, we can see that Africa is about 1.2 billion, but the fortunate thing is that it is not densely populated compared with the rest of the world. And later on, you will see the kind of things that I'm going to talk about. So I personally believe that if we really go into productive agriculture, it could be another avenue to eradicate poverty. Not that we are poor, but at least to eradicate that kind of mentality of whole and cutlass kind of agriculture, this kind of gardening on water. So if that is the case, let us look at this. If we look at the youth, later on, you will see that if we employ, we get the youth and then they get interested in agriculture and they actually embrace technology, we can use that to fight poverty and then it can sustain the economy to a certain level. I'm talking about only agriculture. Why am I saying this? We can see here that if you look at it, agriculture employs 65% of the workforce in Africa. So that being the case, that means that it's a huge area that we have no choice but to develop it very well. It's not only for food, but for export and whatever, high quality kind of things. And it contributes 32% of the GDP of Africa. This is no joke. So these are some of the things that we really have to sit down and take it seriously. Now, it is predicted that by 2030, if we adopt technology and then use it in the agricultural systems, then we are heading for $1 trillion of what you call it, accumulation of, input that we are going to get for our own, what you call it, benefits. So this is really significant that I think we cannot just let it go. For how long we will depend on the donor countries? How can a country, your budget be controlled by others? So these are some of the things. This is why we also have to understand the distribution of each zone and what they can do. Here, I'm showing you based on zones. We can clearly see that we can distribute agriculture and then look at what you call the natural advantages and disadvantages. Now, but unfortunate thing, this is where I think we have to go in aggressively. You can see here that organic farming is almost absent in Africa. Just imagine, look at Ghana, 22,276 hectares. This is peanuts. You see, and it cut across, you can see it's just too low. Because now we cannot rely on chemicals and whatever. They are not helping us much. And this is a continent where people do natural farming and we are not trying to get into this. And this can be done. I quite remember we had in Ghana Operation Feed Yourself. And it was something very successful. You look at Thomas Sankara was able to transform based on the kind of agriculture that they did. So I think there is a possibility, just that we need to sit up. This is where we have to still concentrate on organic farming. Especially look at the quality of cocoa in Ghana and whatever, look at the other parts. You see, if we embrace organic farming and whatever, these chemical fertilizers that we are trying to get outside will not be really, really relevant. So these are some of the things. I'm not saying 100%. And we need to also embrace integrated farming. We need it because the integrated farming here, we will get the source of organic matter to maintain the soil, avoid the soil erosion. I'm not talking theory. I'm going to show you examples. Now, why are we interested in it? Of course, if you want to maintain the soil fertility, then organic farming could be one. You might say it's expensive, but there are different ways to kill a cat. And then we also have to talk about the input. How do we reduce our input cost so that we will be competitive? And then what are the natural resources? How do we utilize them well? And then we are all talking about the population. Now, how do we avoid all forms of pollution here and there? And then how do we improve the quality of our food stuff so that we'll be at that kind of level? So the basic understanding will be that we are going to create what we call a harmonious environment, create jobs. And then we are also talking about fighting climate change and preservation of culture and agriculture. If that is the case now, let me show you a classical example where one of my teammates, who is now also, he just graduated and I think, I'm sorry, he's having his PhD now. So here, this is what he did. We just look for what we call the waste. We are talking about fermented plant juice. And then he wanted to look at it, how he can use it in natural farming. So all the waste and whatever that I gave you an example, some examples. So he came out with this, tried to turn it into something beneficial. And from there, we also work on what we call fermented juice. What you call from what? Fruits and whatever. So again, able to produce some products from here. And at the end of the day, these are some of the things that are being used in the black pepper environment. So these are kind of the things that we need to think about. It can be done, right? Now, this is done in Malaysia, and certainly they have the credit. Malaysia deserves the credit, and they are good in agriculture, definitely. Now, coming down to the youth, let's look at the population of Africa. You will see that we are made up of what? we contribute 16.97%. But what I want to highlight here, like I just said about the density now, if you look at Africa, we are not densely populated. You see, we have this kind of 65 people per, what we call it, a mile of whatever. And we are far behind Asia, Europe, and South America. And this is the most interesting thing. If you look at the continent, the whole of the world, Africa has the youngest population in the world. So it is up to us now. If we don't utilize this advantage, it can come back and fight us, and it will be disastrous. So it's better we empower the youth today. Otherwise, if they turn against us, then everything is gone. So here, look at it. It is only this continent that has this kind of, population. Very, very young population. And we can see, if you look at it here, just look at it. The average age of the African population is 18 years. That is very, very significant. And we can see, look at the rest of the world. You can see here. And then what is more interesting is, if you look at this, part, what we see is by 2100, we can see clearly that most of the population will be between 0 to 4 years. That tells you how young and how we should capitalize on the youth. So this becomes our capital, our resource that we need to work on. And then look at it. If we go a little bit here, we will see that by 2100, what we are seeing, the Sub-Sahara Africa alone, this will be the young population that we have. So what are we sitting down for? So it takes a kind of will for us to do. Now look at the interesting part. If you look at here, what we see, as other parts of the continent, they are aging, we are rather increasing in our youth. This is why we should target them. You see, by 2050, we are hitting almost 1 billion. Assuming we can harness their resources, then it becomes an asset other than a liability. But when you go to, let's say, South Asia, you could see that the population is decreasing because they are aging. And when we come down to this part also, we are talking about Southeast Asia, Asia, and Oceania, the population is also declining. That is a sign of aging. And when you go to Europe, it's well known, it's also depressing. So these are some of the things. So it's like the youth is coming from Africa and we don't utilize them, then forget it. Now, if that is the case, how do we look at smart farming? Now, you might argue and say that, but you are talking about smart farming and it's not practical, a whole lot of gadgets. That mindset is what we want to change. If others are doing it, why not us? So here, let me put it in a simple term. We are talking about, you don't worry how you go about it, your agricultural system, you manage it efficiently so that you produce your produce from farm to table and it is safe and good and the quality is there and you don't jeopardize the environment, then that is considered as a smart farming. So here, these are some of the things. If you can be smart in managing your water system, maybe even if it's traditional and it's efficient, that is fine. If somebody decides to use drone, that will be fine. But we are talking about efficiency. You can be working too much, but your efficiency will be very low. This is why we have to blend with technology. So then you will hear about IoT. IoT in agriculture actually has so many meanings. We can talk about precision agriculture. You are using drones, you are using livestock management and green gases or whatever. No matter how you look at them, the most important thing is how efficient you are, how sustainable you are, and how productive you are going to be without jeopardizing the what you call it, the environment. This is why in certain parts of the world, they are using what we call agro robots. They use robots a lot in working, and others also use sensors. Now we are talking about LED indoor technology. These are some of the things, light emitting diodes, where we can mimic the sunlight. And then from there, we can do indoor cropping and whatever. I'm going to show you digital technology, clouds farming. These are some of the things that we will have to look into, whether we like it or not. Otherwise, we will forever be left behind. So here, this is what we call agro robots. You can see this is miniaturization. You don't need bulldozers and whatever anymore if you are really serious about what we want to do. And these are sensors. You see, if you use your naked eye to look into the field, you might think that every part of the soil is the same. But in reality, no. So when you use the sensors, you will see differences. So you manage your, let's say like this look green. If it doesn't need fertilizer, it doesn't need pesticide, why do you want to waste your money? If this is a place that need it, you focus. This is what we call site-specific management. And we call this temporal, special distribution. So if we have this kind of system, then we should be able to be, we should be quite efficient in that kind of system. And this is what we call light emitting diode technologies that we are talking about. Just like human being, you sleep under the light or whatever. The same thing. In fact, this is even more efficient. I'm not trying to promote this kind of thing, but if we are running out of land and whatever, these are some of the things that we should be thinking about, right? And it's not beyond our means. Now, what about if the technology, what is it going to do? Definitely, you are using light to change how the plant grows. You are not modifying the genes or whatever, no. If it needs chlorophyll for photosynthesis, that is what you are providing. You also want to improve upon the taste or whatever that is there. And we are also talking about, if let's say like we are talking about improving vitamins, these are some of the approaches that we could use. If you are talking about antioxidants to prevent cancer, then these are some of the ways. And then we are also talking about extend the shelf life of your produce. I understand back home when you have tomato, you leave it 1 or 2 days, the tomato is going bad. So these are some of the things. Of course, you do genetic, breeding and all kind of things. Then the other aspect also will be when we talk about flowering and whatever. So these are what we call lead kind of technology. And it doesn't end there. You can even use it for livestock in terms of fish or whatever, for them to see very well, feed and then get space and then metabolize the inputs and whatever. Now, of course, you are talking about digital. Here we are talking about, Amman area kind of vegetation survey, whatever. The drones that we are talking about, they can all play significant roles. Of course, we need to train people to know how to use drones and whatever. Now, when we talk about cloud farming, what do we mean? The cloud farming here is like you have a pool of data that is in the cloud so that you use the data and then try to use it to predict what will be the nature of your soil, the quality, the organic matter, the pesticide, the fertilizers, when to apply, prediction of the weather. So these are some of the things. And we can do these things even using your smartphones and the like. Now, that being the case, these are technology based. What about if we use our intellects, the way we think, the cognitive ability of trying to what we call go into appropriate technology? Appropriate technology does not mean sophisticated technology. So that is what I mean, right? So if we also go into that aspect, then I'm just going to show you what one of our group members is doing. Again, if you look like, let's say, pepper or any in the tropics, one thing that disturbs us a lot will be fungi. And then let's say like fungal example is Phytophthora, or you are talking about other kind of diseases. So here we are using the concept of the soil. You have to use the knowledge to beat the system. That's what I'm trying to show here. Now here, what we do know is this Phytophthora, which is a fungi, normally they like to attack the plant roots like any other kind of fungi. So here, how are they able to attack the roots? Because you grow the system, if the soil is acidic, then what is going to happen? Just like human being, if acid touches your skin, it's going to what? Corrode your skin and then make it a little bit impetuous if you have what they call the fungi coming in. So here, what we are trying to say is, why not we make the soil healthy so that we make it uninhabitable for the what we call the fungi in a way that we'll be destroying the fungi in a very, very ecological way and without using chemicals. These are what we call smart farming. So here, that being the case, this is what we are trying to do now. This problem is an international issue. It's not only related to Ghana in terms of pepper production or whatever. It's quite serious. So what we're trying to say here is, one way that we can look at it is the environment. These kind of fungi, they grow where there are dumpy areas or you have humid conditions. So we cannot beat the rainfall. So what do? The next thing also, you might need sunshine. So this is another enabling factor for the organism to grow. So once they have this enabling environment, this is when they attack the roots and then they affect the plants. So we also have to attack it and do preventive measures instead of relying on chemicals or whatever. So now what are we going to say is that once you have your rainfall coming in and then you are losing your nutrients and whatever, then the immunity of the plant is jeopardized. So here, once you apply your nutrients like in the form of fertilizer and the soil is acidic, the first thing that will happen is your nutrient will not be utilized very well, especially phosphorus. Phosphorus has a very high affinity with aluminum and iron. So once you apply, instead of the plant to take it, aluminum will anchor iron. So the plant will not get it. So that being the case, it means that we need to find a situation to handle that situation. And again, if you have an acid soil like in the tropics, you are going to have hydrogen ions coming in. Now, once the hydrogen ions come in, they are going to they're going to destroy your roots. So we need to create this kind of environment. How do we do that? These are some of the things. So I'm summarizing the triangle for you to understand when we talk about smart farming. Here we are using our brains without using the technology yet. So here we have the rainfall, the precipitation, we have the acidity coming in, the plant becomes susceptible, and therefore the microbes will have a free day and then they attack the plant. So what my PhD student is doing now is to look for a very sustainable measure, and then we depart from what we know. Now, we all know that the conventional way is to use chemical. This is corrective measure. We want sanitation, like you clean the area, you make it very, very, hygiene and very, very clean. But that one also takes a lot of money and whatever. Now, biological control also is not working very well. And then here we are also talking about drainage. Of course, dumpy places, you drain or whatever. But remember, if you create drainage also, you might create erosion and runoff because they are grown around slopes. Then the other part is you grow healthy plants. Once they attack, you just cut them and grow healthy plants. This will not be sustainable. And others are taking about organic approach. So we want to eliminate all these things and then come out with a very, very practical solution. This is what we call, smart farming. So here, people are also saying we use what they call gene resistance or whatever. Again, it's still not working. And then we are talking about root infusion, also not working. So this is why our PhD student is trying to go into this aspect. So what is going to happen? I'm relating it to Africa because we also have this. So we use the soil approach where you can use sometimes any material that is quite high in calcium, or you have a material that is high in silica. But here we are talking about rocks. We are not talking about chemicals. These are natural products. So what we will do is the intervention is like this. Once you use this approach, what is going to happen is, well, let's say like your hydrogen ions, they are already been neutralized because this is more or less like a Lyman effect. So the calcium now will get into the root and protect the roots. So once it gets protected, what is going to happen? Remember now the soil is not acidic. Therefore, the phosphorus that you are producing now will now have a time, it's not going to be hooked anymore. And then the phosphorus can now go into the plant. And phosphorus is very important for plants because for a plant to root effectively, take water and then nutrient, you need phosphorus. So here we have solved that part. And now, because we are also solving the other aspect of what you call silica, you need silica. Silica is very important to protect plants from being attacked. They form a waxy layer around the roots. So here, once you do this, what is going to happen is it's like you have created a shield. So you see, when these kind of fungi come in, they just go there and they cannot attack anymore. So now they have no choice, but they have to die. So this is the practical way that we are working on it now. So these are some of the approaches that I think I can share with you. So when we talk about smart farming, this is why we need the youth, so that they can think properly and then think out of the box so that we can move on. Therefore, with this approach, we are eliminating the acidity aspect. We are also eliminating the susceptibility aspect, and then we remain the plant in a natural system, and then that is how we go. Now, from here, all that we can say is that we have settled the problem, but you have to know what kind of materials. So I'm moving you to other systems that we can use, and then the youth should come in and then pick them up. So there are different types of material that you can talk about: zeolite, silica, manganese, compost, biochar, or whatever. All these things can be used. So the waste that we have back home should be able to do. So what is the vision for African, youth, for them to go to agriculture? The first thing is that we must embrace modern technology, and then we use new methods that are related to what? natural systems, and then we'll be productive and we don't harm the environment with time. For me, this is my vision for the African youth. The next one will be, we should try as much as possible to maximize our input and whatever. So here means that even let's say we don't have enough land, we can use the same level of input, but try to maximize our output. That is something what we call precision agriculture. The next one will be, okay, assuming we also don't have that, we have the same productivity, then what we can do is to reduce our input. That could be very, very important also. And then the third part will be, if possible, we can have greater productivity, but we reduce input. So this is what maybe the youth should take into, not what we are doing. You just buy your fertilizer, you don't know the soil properties, and then you just go in. This will not help us. So the mission will be, we must pursue agriculture as a business. That means that it must be a lucrative system, and then we must focus on agronomic practices that are in harmony with nature. If we can go into that, then we will not deplete the soil, then we will conserve the soil till what we call it eternity. The second aspect will be also, when we talk about the goal, we should pay attention to the root cause of our problem. Just like example, what I just showed you now. We are paying attention to the root cause of the problem. You get what I'm saying? And address the cause of the problem and not just cosmetic kind of things. If we can do that, that will help us a lot. And the other aspect will also be that what should be the objectives. So we must emphasize on soil, plant, and animal production in terms of health. That will be in terms of agricultural efficiency. That is number one. Number two, we should also look into what we call responsible socio-economic efficiency. That means that whatever we do, we must have the masses in mind. It is not about you alone, it is about everyone. That kind of context should be what the youth should look into. They're not these kind of selfish games and you don't care about others. And the last part will be, we also have to talk about responsible environmental efficiency. These are very, very important if we want to be sustainable. Now, if I have already said that, then perhaps as the young who are going into agriculture, perhaps we might say that optimization of your resources to be outstanding in your production should be the cornerstone of your work. If you cannot be outstanding, you cannot optimize your resources, then you are just as inefficient as anyone. And we don't want the young generation to do that anywhere in the world. Otherwise, it's just like this. You have this drum. If you have the drum and you want it to be full with your output, definitely you need to block the leakage. So if we don't block the leakage, then we are not going anywhere. So this is where now African agriculture is leaking seriously. We need the youth to block the leakage for us. Now, let me come down to soil colors for you to see how easy, if you are in the agriculture business, what you can use the soil color to do. Like I just showed you, these are the colors. So whenever you see a color that is dark brown to black, it is not always true that it is highly organic. It is possible that it could be, but remember, organic soils are generally acidic. So what you can say is dark brown to brown could be that, yes, the soil is a little bit fertile or whatever, but generally, if it's not acidic soils, then it should be fine. But if you have a soil like this, even though the top is dark brown, it does not mean that it's fertile, because the pH is less than 4. And below it is yellowish because of sulfur. Therefore, the pH will be like 2 point something, just like sulfuric acid. So this is why you need to understand soil color. This is an example. This kind of soil, no matter what you do, you would never, no kind of technology, unless you drain and then wash the acidity from the soil, liming will not help you. It's not a productive venture, because the reddish color that you see is iron. It undergoes oxidation to produce a lot of hydrogen ion to make your soil acidic. This is why the plants are not surviving. So soil color alone is telling you a lot. Now, what about when you see white to light gray? When you see white to light gray can tell us a lot. It can tell us whether the soil is being leached and you are losing your organic matter, you are losing your clay, you are using your nutrients or whatever. This is what we call a bleaching zone. So when you see here, it tells you that the soil is losing a lot of nutrients. So you need to do something about that. This is just one aspect of the color that you can talk about. Now, gray also can tell us whether the soil is waterlogged or not. Do you need drainage systems or whatever? We'll talk about that later. Now, it can also tell us the stage of the soil. It can tell us if it's a sandy soil, then it tells us that the soil is a young soil. If it's a young soil, you don't have topsoil, you don't have loamy soil, you don't have good soil. So therefore, what is going to happen here could be that you need organic matter and you need to do a lot of work. If you buy the land, then you will be in trouble. So those are some of the things, right? Now, this is the bleaching that I'm trying to tell you that you need to be careful. You need a soil scientist to advise you before you go into this. Now, based on this also, sometimes we will also have a situation where this color is really telling you that actually it is a calcareous. Maybe it contains a lot of lime, calcium carbonate. That means that your pH will not be acidic, but you will have problem with phosphorus. And then sometimes it might tell you that it contains a lot of salt, salinity. The soil is saline. Therefore, if you don't match it with a saline type of tolerant crop, you are going to do bad investment. So you see, the soil color alone is telling us a lot. This is why when you try to crop here, it's not growing very well because it is either too much of calcium carbonate or it is a little bit salty, right? Then we can also talk about the next type of soil color, that is what you call bluish gray. When you see bluish gray, what is telling you here is that the soil is really under the influence of too much of water. So when you have too much of water, like you see here, that means that there is less oxygen. So a plant that cannot tolerate an anaerobic condition can never survive here. Therefore, you need to have your drainage system very well, and you have your drain system very well. So this is another example where you see beneath the soil, this is going to happen. You don't need any expert. You have to understand that you have problem with oxygen flow, and the soil is going to be very compact. Now, the other part will be what we call mottling. You just look at the soil, you see certain part of the soil look reddish, certain part of the soil look grayish, like a variegated leaf. So here, what it's telling us that the reddish part is too much of iron. Now, when you have iron and it corrodes, you see when you have your iron sheets and they corrode, you will see that they look a little bit reddish. So here, oxidation is going through. So that means that when you go forward and plant, once your root touch the iron, they will die because of iron toxicity. Now, the grayish color that you see is where once a while when there is rain, then the water gets stuck in that area. So you have dual problem to settle. So soil color alone should tell us a lot. So that's what I'm trying to do. Let you understand. So the youth will have to understand this. And if I were to design a curriculum for any educational system, they must learn right from class 1. For me, that's the way I will look at it, so that it becomes part and parcel of them. Just like handphone or gadgets are becoming part and parcel of the new generation. This is how we have to catch them young. So now, if you want to see a soil that is well drained, you can see it's a little bit light here, and you don't see bluish gray or whatever. So this soil is well drained, and you don't need too much of what you call drainage system. However, here, what is telling you is you are going to have a lot of iron. Therefore, the soil might be acidic, and then the iron has spread. So you need to look at it. So that is how it's going to look like. So these are some of the examples that I can share you, what I've shared with you. So you see how reddish a soil is. So the color itself should tell you a lot. So these are some of the examples that I can share. Now, let me bring you down. Not every soil that you see that you can claim that is fertile. In the soil science, we look at 3 things: the biological aspect of the soil, the chemical aspect, and the physical aspect. When they interact, then we can talk about biological is the biodiversity that you have just been told. Chemical can be pH, organic matter, and the like. Physical can be texture, structure, hydraulic conductivity, infiltration, and the what. Getting to the end of the lecture, I'll come down to that. So here we want to see the what you call the ecological system in a form of synergy, that they all come together. The physical part is there, the chemical part, the biological. So when you have this, then we say your soil is fertile. So don't just look at the soil and then you say it's a loamy soil, it's a sandy soil, therefore whatever. No, we need to be careful about this. So the core value here will be, if you look at it, African youth, we challenge you to have your mind set up to go into agriculture. Look at it as a business, just like any other business, and try to make the good use of your plant, soil, and animals, and then come out with something extraordinary. This is my challenge to the African youth. Now, for us to go into that, then you have to know 3 laws to get to that level. There are 3 laws. The first law is what we call the law of interaction. So we need to understand, when we talk about the law of interaction, we are talking about how the physical, chemical, and biological system interact. So if I were to pick an example, we have positive interaction and negative. Let's say you are going to agriculture and all that you know is chemical fertilizer. And for you, chemical fertilizer will boost your yield. So if you apply your chemical fertilizer, let's say here you started, then your yield start to increase. So in this aspect, we call it positive, interaction. But in terms of environment, it's negative. But when you go biological or organic, or you go smart farming and you get this kind of response, then it's considered as positive. Now, assuming now you are going too much of chemicals and whatever, and your yield try to increase, and now because of too much of chemicals, then you are seeing a yield depression or pollution is coming in. So this is what we call negative interaction. This is why I'm stressing on optimization of your resources to remain relevant. That means that your interaction is negative. Now, the other aspect that we can talk about is zero interaction. Sometimes there is no interaction at all. Certain reactions. If you look at this diagram where we are talking about pH, fungi is not responding very well with increase in pH. So this is zero interaction. So you don't have to spend too much time trying to fix this kind of problem. Now here you can see bacteria is responding to pH. As we move around, then it becomes stable. So this is where you should focus and manage. Now the second law is called the law of limiting factor. It's very, very unfortunate that you see people go into agriculture. Let's say you are going to plant, let's say maize, you are going to plant rice. They say, okay, I go to the market. The first thing I need to do is to buy fertilizer, NPK. You never analyze the soil and look at what is the limiting factor. You just buy the fertilizer and then you just apply. This is not a good approach, and it is never considered smart farming. So smart farming means that before you start, you should know the level or the capability of your soil. Let's say you are the farmer and then you just drop in and then you get to this level. You want to plant. You never bother to check the level of your nutrient. You just buy your fertilizer. If you look at this, you are not being scientific and you are not being smart in your investment, because if you look at the threshold, the limiting factor here is P. Nitrogen you have enough, potassium you have enough. Why should you go and buy potassium and nitrogen? Instead of buying NPK, just buy only P so that you can boost it. So you see here, when you increase the amount of P, you can see this is why your yield increase. Now the next stage is assuming you want to boost your yield further, then the limiting factor here is going to be K. So you focus on K and not too much of P and N. So once you do that, you see, because you have now focused on NPK, you've been able to boost your yield. So if you want to remain relevant and you want to be ahead of your competitors, then you are looking into, I'm not saying it's going to be one by one, but this is the way you look at the limiting factor. So if I want to get to this yield, then I need to focus on magnesium and sulfur. So this is what we call the law of limiting factor. So when you go into agriculture, look at the limiting factor, fix that limiting factor, and leave those that are not limiting. So this is an example. Of course, you cannot continue to be moving like that. You will get to a point where you will have the law of diminishing return coming in. So here, that is where you do your optimization. So this is an example. Let's say you are fixing your limiting factor, fixing. So here, this is the amount of nitrogen fertilizer. So the corresponding yield is what you are getting here. So here, let's just assume you decide to increase further. You are increasing your nitrogen to about 180. And you see here, you are not being productive at all because this amount is not necessary. So here, this is where if you go beyond the optimum, you want to get to the maximum, there could be depression. So here, it doesn't make economic sense for you to go further. If you go further, then you're going to have yield depression, and definitely you are going at a loss. And this is exactly what is happening to our old folks, farmers, our grandparents, our fathers, and whatever. These are some of the things that we need to change the mindset. And this is where we need the youth, right? Now, the last part is if you really want to optimize, then that means that you should stop here. The rest are all not relevant. So once I have said that, then we will move on to another stage. So here, for us to get into this, we don't want too much of chemicals or whatever. Then we have to go into what we call conservation agriculture. So what do we mean by conservation agriculture? The rule is very simple. We don't want you to degrade the soil. So we want only three things if you can do that. Number one is we want minimum tillage. Minimum tillage means that you only till the soil which part you want to crop, and that is it, so that you don't waste what we call it the whole soil. So this is what we call minimum tillage. If this is that, these are the parts, so you don't leave these kind of areas bare, so that we don't have erosion and whatever, permanent covering. Then the next one is what we call the permanent cover. This is it. If you can handle this, because every time you are recycling your organic matter, whatever, it's going to be very difficult for erosion to set in, very difficult for runoff, and definitely you're going to conserve your nutrients very well. And we can also talk about crop, what we call it rotation. It's very important. Monoculture can have a lot of effect on the soil. So we can also think about that. Now, the biological farming that we are going into here, we are talking about make some profit by use biological means, but at the same time, you don't jeopardize the environment. So if this is what we are talking about, these are some of the things. If you are going biological, we don't want this kind of thing. You have too much chemicals. So here, the drain that you see here is because of nitrogen and too much of phosphorus. So if you are going biological and you optimize your chemical inputs, then we should look at this. So when we look at your drain, it should be as clean as this. That means that you are using less what we call chemicals and you are focusing more on biological. So these are some of the things. So the note here will be, we want to do preventive measures. We are not interested in mitigation. Mitigation sometimes might be too late, or corrective might be too late. So the youth must be more of preventive work oriented than to go to the other three aspects. Now, getting to the other part will be the precision farming. You will hear so many things. We have what we call precision farming. Is the same as site-specific farming. It's also the same as smart farming. All that we want you to do is to be smart enough to use your input to get optimum whatever output. That is all that these kind of terminologies are. So don't let them scare you. This is why because some also are looking at it that because we are running out of soil, we are running out of land, we would not need huge tracts of land now. So we call something future farms. Future farms mean you can even stay in your, in your house, and you can have just 1 hectare or 2 hectares, and yet you can deploy the technology for it to work for you, so that you work and then see. So you can monitor, let's say like your drones can monitor the quality of the soil. You can use your robots to monitor if you want to apply some fertilizer, or you can even use your tractors to do your sensors for you. Even we have what you call texting cows, where you have sensors with the cow so that you can communicate with the cow, whether the cow is going to labor, whether it's going to, you need some milk, or is being infested by diseases, and then you manage your data. So this is what we call future farms. So you don't need that huge tract of land. And like I said, you need your drones to also look at your spatial distribution so that you can handle the soil very well. You can imagine if you don't use the spatial distribution, this is actually how the soil looks like. But you see, because of this, you are managing the soil very well. Now, and then of course, like I said, your phones and whatever, and then you can even put it on your tractors. And as you move, you can see your map. So the color here will tell you how you manage it differently from, so you have what you call your maps. You overlay the maps, and then you can manage your soil. So these are the things that our youth should look into. Look at how beautiful it is. If you sit here and then you do your work, you are just like anybody who is sitting in any office. So these are some of the things. And even your phones also can check the diseases. So you can even be outside and checking what is going on, whether the plants are affected or not. We can also look into that. And then, of course, now we are talking about crop insurance. You don't want to argue with the insurance companies or whatever. You have the drones to see if it's a natural disaster, the proof is there for you to do your claim. So these are some of the things that I think we have to take very seriously. Now, if I were to go into other parts of my talk, then maybe I would like to look into what we call the near infrared. Let's say like you are in the vegetable industry, you are in the fruit industry or whatever. we can capitalize on the same sunlight that is coming. Most of them will be scattered, but what comes to the plant is what we call the visible range, together with what the near infrared or the infrared zone. So the spectrum, if you understand it, you should be able to tell you whether your plant is diseased, is healthy or not. So here, this is what I'm trying to show you. This plant is not healthy because the near infrared is not moving well. And then you can also see here. So once you have the sensor and then you can get the near infrared, then you are already true. So this kind of thing, we have simple gadgets that as a farmer, you should be able to have. So it is good for you if you have this kind of gadget. It can quickly tell you what is the organic matter content. Can it supply, can it hold your nutrient, can it prevent erosion or not? It can also tell you about the measurement of the variables that you need. Example, the nutritional status of your crop. It can also tell you when are you going to harvest your crops, timely that you get good market. Fruit processing is also there. It can also tell you the grain composition, the fatty acid, the proteins and whatever, it can tell you. And then it can also tell us give us a lot of information about diseases, pests and toxins. Remember, sometimes you want to export your products, all these things will be checked. And then you can monitor your drought. You can also look at the quality of your fresh fruits and the like. And then we can also talk about even fish and whatever. You can also go into that. And it's very, very crucial for soil testing. And it's very, very important that you also look at it. If you, let's say, like you have your waste product and you want to generate energy from it, you can use the near infrared to also help you. And breeding programs to come out with resistant genes for your plant also could be done. So these are some of the things. And then we can even use artificial intelligence to also detect what you call diseases. And then we do imagery. We are talking about image technology so that you can know. You just scout around and you can see whether your plants are doing very well or not. And even you can use the concept of acetylene to find out how fast your crop is going to ripe, and especially if you want to export. This is where you need to understand this kind of near red and then what you call it, the emission. Back home, we grow a lot of banana. You are talking about, cassava and the like. All these things can be done with the latest technology with the youth. Now, again, these are some of the things. So many things, diseases and whatever can be detected. Now, we don't have a choice because we are also running out of land. We also have to go modern. Therefore, we need what you call urban farming. So I'm just giving an example. One of our students who is trying to work on her rice, and you see, he's just using a trough. So you are using a trough and then you use it to produce. That itself, let's say you have a land backyard in your area, whatever, that is lying fallow, you can use it. And this is a classical example that I can share with you. This is what we've been doing, and you can see what we are growing. So I think everyone can do this. If you don't want to have a big land, these are some of the options that we have. And you can see how beautiful they are growing, and then you make some money out of it. Now we are also talking about vertical farming. Why am I bringing this? I personally feel that the kind of buildings we are building now should be reshaped so that we can do rooftop kind of agriculture. So these are some of the vertical farming that we are talking about. So this is what you call rooftop farming. And I believe that this is also the order of the day. It has a lot of benefits. And if we are talking about that, look at this. I would really prefer that maybe we need to change the way we are building now. Because if you are running out of land, how can you do a rooftop farming when you have these kind of buildings? It looks so beautiful, but at the expense of the land and other aspects of our crop cultivation. So these are some of the things. This is classical, a very good example of rooftop. This is rooftop. It's not on any soil. You get what I'm saying? So these are the kind of things that we should tell our youth, encourage them to go into these things so that they can save us. It's not like the moment you go into farming, that's the last option. That will be a poor man's job. That is not the issue. So what are the benefits of rooftop? Clean air. You are talking about you can produce food. You can support urban wildlife because of you have all the wildlife around. They can land on your roof or whatever. You are talking about it can also reduce what you call storm. You see, sometimes the storm impact on your whatever, and it can even reduce runoff. It can also improve upon the energy. You can use it to build your own biosource of energy. Now, the next part, getting to the other juicy part, will be aquaculture. Now remember, the sea is being polluted. We are having a lot of problems. Our fishermen go to the sea, they are claiming they have problems or whatever. So this is where we also have to go into aquaculture. You can do it on land. So these are some of the things that we should encourage our farmers to do. And then we are talking about hydroponics. Hydroponics also should come into our ways. You see how beautiful it is. We should just go into this kind of farming. Very, very important. And then you are talking about aquaponics. Aquaponics is a combination of aquaculture and then hydroponics. This is also, and there is a mutual kind of thing. You have your fish will be given what we call it, let's say like the plant, some sort of nitrogen in a form of ammonia changed to ammonium and nitrate. And of course, the fish will also get its water being filtered by the plant, and then they can also live. And then they can also get some source of food. So this is it. So this is a classical example of what we call aquaponics. And then we can also even, now we are talking about aeroponics. Aeroponics means you don't need a soil, you don't need water, but all that you need, your nutrients should be suspended in a what? In a steam form, in a mist form. So here, that is what we call aeroponics. It's suspended in the air. So here you have your nutrients, and then you plant your plant, and then you have a blower. So this is a mixed blower. So the mixed blower is blowing the water together with the nutrient so that the plants can take and then they grow. These things can be done in the urban setup so that you can get side income and still we are working on. So this is how we should make agriculture beautiful. And then you see, can you imagine, this is what we call aeroponics on a large scale. You can see, you just have to be creative enough for you to go through, right? Then we are also talking about fertigation. It's not something new, but it's also another viable option that we need to consider. It's not everything soil, soil, soil. Fertigation can be, you just have your liquid fertilizers, you pump them through the soil, and then there you go. So these are some of the things that we can do. And you see, these are some of the beautiful things that I can show you. And these are all realities that I think the youth should look into. We can also run away from agroforestry. Definitely, we might need agroforestry because we might have rural areas, sub-rural, sub-urban, or whatever. We want to conserve the environment. Then we can also not run away from agroforestry, where you are bringing plant agriculture and then forest together so that they come in a way that we can harness situations and get our resources being utilized properly. This is one of the important aspects to prevent what we call deforestation. It's key to what we call improving, this kind of breaking down of our rocks, our forests and whatever. So basically, if I were to summarize what agroforestry is, it's just like you are bringing agriculture and forest together so that we get the benefit of the forest and the agriculture in terms of timber, food, fuel, or whatever that we need in a very harmonious way. That is all that agroforestry is about. And that is going to be a big solution for what you call soil degradation. Now, I'm going to share with you some of our personal experience. Then remember, I did talk about limiting factors. This is what is going to happen. Let's say you are just a farmer, you are interested, even you just buy your nitrogen fertilizers, you don't know how to manage your nitrogen. The moment you apply the nitrogen and you don't manage it very well, what is going to happen is there will be ammonia coming out. You are degrading the environment and your nitrogen is not being utilized well. Now, this is the consequences of you not being able to understand your farming system, and too much of nitrogen or phosphorus. This is what is going to happen to the environment. If you don't listen very well, you might end up destroying your own self. So these are some of the things this is why we need to understand what we call modern agriculture. Now, let's say like phosphorus fertilizers, you don't understand the soil. Like I just said, if a soil have iron and aluminum, you have to be very careful with the way you deal with the soil because it's already acidic. So when you apply your phosphorus fertilizer, it's just like you are throwing away your money because the phosphorus, it will be hooked by aluminum and iron. So once they are being hooked up, they are never available for the plant to take. So then what we really want is, if you are a very good you have the technology, you know how to grow, we want the phosphorus fertilizer to go to the plant like this and leave iron and aluminum. That means you need something that can hold on to aluminum and iron. This is where I'm leading you into our practical way. We can use organic systems to do this. So now the next thing will be, because You are also talking about phosphorus. Phosphorus also have the similar effect on water, just like nitrogen. Now, potassium also is very mobile. Therefore, when it rains, especially in the humid tropics or in the semi-humid areas, what that you are doing is you are throwing your money away because the potassium is being washed away and you have just a little amount of potassium for your plants to use. So here, with the rainfall, it means that your nitrogen is not efficient, your P, your K, and whatever, because you just didn't take your time to understand the mechanics of agriculture. So these are some of the things. Therefore, I'm going to show you how to reverse this situation. You, the youth, or whatever that will come in, these are some of the things that you should go beyond the limit, this kind of chemicals. So I'm showing you organic systems. So here, what we are doing, we have been doing so far is to use organic system to fix this kind of problems and then get maximum output of it. So what I can say here is when you use organic system, normally you don't need to have too much of liming to neutralize your soil. It can serve as a lime. And then it can also detoxify the soil from iron and aluminum, just like human beings, once a while you have to detoxify your system. We can use it also to detoxify. And remember, we can unlock phosphorus. We can make phosphorus available instead of it being taken by iron and aluminum. So, and then we can also have this system where when you have the organic system, organic matter in your soil, it's able to hold your nutrient, it serves as a sieve, and it's like a shock absorber. Therefore, you may have less erosion, less runoff, less leaching. So these are some of the things. And it will also buffer your pH. You see, the problem with soil pH is if you don't have organic system in it, the pH can easily become acidic and it can easily become basic depending on the situation. But we want to maintain a certain equilibrium so that it will take care of the plant that you are growing. This is what we call soil buffering. And the conditioning of your soil, just like human beings, like ladies, you condition your hairs and whatever. So the conditioning also can be done to the soil using organic systems. So what do I mean? These are some of the, the technology transfer that we've been cutting across the country and then teach farmers together with certain Malaysian agencies. And we have been successful so far. So this is one of the examples that I can show you. So once we produce, we teach the farmers, these are the kind of systems. So they use their own waste. They don't buy the waste. If you're a rice farmer, you use your rice straw or your paddy hacks or whatever, then we teach you how to improve upon it, produce your organic system, and then you are going to apply them. So these are some of the things. Now let us look at it. It's not only solid, we can also use in terms of liquid. Remember, if you want to go for hydroponics, aquaculture, or you want to even go for fertigation, these are some of the things that we should think about. So if we are talking about why the waste, we are talking about waste because I've given you the background. Now look at what the organic system can do that chemical cannot do. And you don't have to waste your time too much on chemical. This is a conventional type of practice. Let's say you see the soil color. Remember, I brought your mind to soil color. When you see this color, it is telling you this is very likely to be acidic. Because if the color is grayish after you detoxify the soil, then that is fine. So if you don't do anything about the soil and you just apply your chemical fertilizer, the color will remain. And then you have not been able to condition the soil, you have not detoxified the soil. But if you use the approach that we are now advocating, you can see the color of the soil has completely changed from yellowish to grayish. That tells you that the soil has been neutralized, it has been detoxified. So there you can go. Within 24 hours, you can do your planting. And you can see clearly the difference now. You see, this is the conventional. So if you are not applying smart farming, here we are not applying any sophisticated materials. This is where the youth, I will employ you to use your brains and the cognitive ability. So here you see, if you are a youth and then you have had your degree, your master's and whatever, and you follow the conventional thing, this is what you are producing. You are never reaching your optimum. But when we come down here, we can see clearly that because you have conditioned your soil, these are practical things that we have done. It's not just copying from internet. So this is the difference. And you can even see the grains. And when we do this, we are able to harvest almost 2 weeks earlier than the conventional method. And we are able to double the yield of the, what they call it, whatever we are doing. So here, this is one of the work of one of my former students, a Ghanaian student, who has just graduated and gone now. He's a lecturer at University of Ghana. This was his PhD work. So you can see here, we use the concept, and then this is what is going on. So you can see clearly, those that you see here that are not growing well, these are the conventional one. The one that you see them prominently growing, these are our approach. So you see the conventional one, you see how is it? You see, so these are some of the things that we talk about when we talk about smart farming. And at the end of the day, you can see this is a conventional, and then look at what we are producing. Now, these are, normally you do this over a period of time. So he did it almost for 3 cycles. Then we become convinced that the technology is working. Then we can do the transfer. So these are some of the data that I'm trying to show you. And for us, what we do here, we have our students, the young ones, we send them to the field, and we want to get them into the system as much as we can. So this can be part of their practical training. So right from the beginning, they are being absorbed into the system. So they will look at agriculture as a serious business. We have also tried it. One of the other students also produced biochar from waste product, and we tried them on vegetables, and you can see this is the conventional type, and this is our approach. Again, you can see clearly the difference. This is all when you are able to manage this. Now the shock is here. This is just a final year project. I mean, no, this part is a final year project that we wanted to see what is going to happen. And this part is one of my PhD students who have also graduated, and then this was his PhD work. So you can see clearly what is going on. The plants are now doing well. Now you can see, when you look at it clearly, when you use our intervention, you can see clearly that the plants are growing far better, and this is only 25 days. Now look at the conventional one. So these are the realities that we need to drum into the ears of our youth for them to go. So remember, can you imagine? This is just a final year undergraduate student producing outstanding results. And you have agricultural extension officers, and you cannot produce this for your country, then that is a very big disservice. So let us take things seriously. And you can see clearly, when you do the right thing and then you use the right technology, this is what you get. For how long should you allow your farmers to go and produce this kind of output? This is really not acceptable, and this is what we should be very serious of. Now, in terms of pineapple, I mean, all things have been done. You have a number of students working on pineapple. Myself, I work on pineapple during my postdoc and PhD. So these are some of the things that I think that we need to go into. I understand Ghana is producing a lot of pineapple. Nigeria, other parts of the world are producing. By you generally producing mineral source, you can see how beautiful it is. So these are some of the things, and it's all about technology. Now, even to the extent of measuring gases, another 2 or 3 students are also measuring the gases. Much as we want to produce, we also don't want to pollute the environment. Therefore, we also want to see into this. So these are some of the things. Now we have gone into a bigger scale across the nation. Now, before we went in, we had to convince the farmers that, look, this is what you are doing. You see how miserable your farm is. But if you come and you adopt our intervention, you are going to have a dramatic change in your life. So this is how we manage to convince them. And normally here you have to give training, clinics, and whatever. That is the beauty of this country. They are really mean business. They really know what they are doing. And we have no choice. We have to learn from them. So this is what they are doing. You have to give clinic, let them understand what they are going into. Then from there you start. It has no any political implication here. They just want them to do the right thing to solve the national issue. So here, that is what we did. So you see, these are some of the farmers. You go there, you teach them the technology, and they are willing to adopt. So this is what is going on. And then you can also see, now we are talking about hundreds of hectares or whatever. So these are some of the things that we did in other parts of the country. You bring in your whatever, and then you start to prepare your land. You remember I told you that if you detoxify the soil, it must look a little bit grayish. It shouldn't be reddish or yellowish or whatever. So you see, we have been able to detoxify or condition the soil. Then from here, you just move in, and you can see how beautiful the rice is growing. So this is possible. And I'm talking about, especially back home, we are talking about planting for food and jobs. How can it be if we don't have this kind of technology? Then it's just something that we have to be very careful. It's a very good concept, but I think that we need to step up the game and understand exactly what we are doing. So these are some of the things that I can share with you. And these are practical things that have been done, real-time farmers. Just because you are being smart and know how to manage the soil, and that's it. And here we reduce the fertilizer input, and we don't even include all sorts of so many chemicals and whatever. So this is what is going on. If you don't believe me, this is me standing very happy looking at what is going on. So then you can just see this is what we can show to you, and I think we are very proud of it. And it's not only me, together with our group. And we have another project that is ongoing. We are going to papaya, and then we are also looking at another PhD candidate is working on it. We are using what you call a mineral rock, highly weathered rock, and then you just grind the rock and then you just apply it. So this is a specialized type of rock. They have tunnels that can hold nutrients, and then they can prevent the nutrient from being lost, and they can capture carbon dioxide to, avoid the greenhouse effect. This product is what we call zeolite. So here we are also been able to go through. One thing about the zeolite is we are interested in the silica content because it will help us to protect the plant, and it's also a beneficial nutrient. So from here, what we can share with you is the outcome. Now you can see the outcome for yourselves. After applying the concept, just think straight and then get the concept. This is the kind of papaya we are producing now. And this is already in quite a very good journal. So the next part that we are also talking about, these are the economic benefit. We are able to double the yield, and then we are also the taste. Remember, I did tell you the near red, infrared. So here we are also having the taste, and then the nitrogen availability is there. The pH has been improved, and we are talking about, instead of harvesting around 8 months, we are able to harvest 6 months. And the weight is far better than the conventional one. So these are some of the things that I can share with you. So the other parts that maybe the youth back home, you do agriculture in the way of capturing carbon. That is what you call the carbon footprint, so that your country will be able to participate in the carbon sequestration as carbon credit. So because of this, we are going into what we call enhanced weathering rocks. We are using the rock to boost the biodiversity, just like what you heard. And we are using also to boost crop productivity, post-harvest management and losses, and then socioeconomic being of the situation. Now, let me end up my story by going into oil palm, a very simple one. Ghana is very unfortunate. You have Nigeria, you have Ghana, you have other parts of the world where oil palm was got and then brought to this country, and they have perfected the technology or whatever. So we don't have a choice. We have to learn from them now. So this is an example of the architecture of the oil palm. The oil palm actually is an interesting plant. It can have a root extension of up to 4 meters horizontal and 1 meter deep. So here, if you understand the architecture of the oil palm, you should be able to, manipulate the system and see. So this is where I'm going to show you the concept that we are bringing here now. If you don't manage the rooting system and understand the soil, this is what you are going to get. And this is exactly what is happening back home. We need to step up the game again to look into the oil palm industry and see exactly what are the limiting factors and fix them. I'll show you what we are proposing. Otherwise, the yield will remain like this, right? So then this is what we are doing. If you don't believe, these are the kind of things that I can share with you. Even how you sample the leaves, how you manage the oil palm is very, very important. It's not just plant and get the output. It will not take us anywhere. So these are some of the things that I can share with you. Here we are trying to show which part of the front will you cut and then analyze and see whether the nutrients are deficient or the plant is growing, what intervention we have to do. So those are some of the things that I'm trying to share with you here. Now, what needs to be done in the context of Ghana, Africa and other parts of the world as far as oil palm is concerned, especially when you have too much of rainfall. Now, oil palm is a heavy feeder of nutrients. Therefore, when it rains and you don't apply your fertilizer very well, they are going to get leached. Once they get leached, it's like you are throwing your money away. So once the plants are going out without nutrients, then we are not being efficient at all. So what we are proposing is, perhaps we will look for what you call it degradable biopolymers, so that you put your fertilizer in and it should be able to allow the nutrient to diffuse around so that you conserve the nutrient, release them timely, only when the plant needs them. Just like human being, you eat only when you need food. You don't eat because you want to eat anyhow. So these are some of the things that we are trying to work on now, so that once you have this kind of system, your nutrient management become efficient and then you become productive in your agriculture. So these are the things that we are trying to do. And again, the one who initiated this is the one who just left and worked in the University of Ghana, and I'm proud of him for coming out with this kind of concept. So these are some of the things. So one bag can take 4 plants, then it can diffuse the fertilizer for you, and it will remain there until the lifespan is gone. So ladies and gentlemen, these are some of the things that I think I'm trying to challenge the African youth to think beyond what they are seeing. So my last food for thought will be, those of you who are interested in agriculture, understand the soil. So this is a summary that I'm giving you. Know the physical properties of the soil very, very well. Unfortunately, I can't teach you now. When we talk about the soil physical properties, we are talking about soil color. We are also talking about soil texture. Soil texture is very, very important. You have loam, you have silt loam, clay loam, sandy loam, whatever. They all have their indicators to enable us to manage it. The soil structure is very, very important. We are talking about porosity and permeability of the soil. You should also know how compact your soil is the bark density or the particle density, very important for the plant roots, and how the infiltration to avoid erosion, to avoid runoff, leaching of your nutrient, then that is very important. Aggregate stability. We want granular type of soil. We don't want a compacted soil without structure. That will not help you. We don't want a soil that easily collapses also. The compaction must not be too much so that the biodiversity is affected. Your plant root, water cannot move very well, oxygen cannot circulate. Therefore, we need to improve the water holding capacity by how? This is what I just showed you, using organic matter and the like. Now we are also talking about the available water capacity. You see, water in the soil, not every water is important. We are talking about available water that is available for the plant. That is what we should manage. And the only way you can manage this is to manage the pore sizes, macro, meso, micro. How are you managing them? When the soil is detoxified and you have a very good organic matter in the soil, this can be settled. Residual, porosity should be those that the microbes can inhabit, the roots can inhabit. Now, potential productivity is very, very important. And then your surface hardness. We don't want a soil that the surface is too hard like a concrete. That one is not going to help because there will be no root penetration, there will be no water penetration. This is why we have to know the soil resistance. So all these things, you as an agriculturist must be well versed in this. Hydraulic conductivity, how would the soil water move? Is it moving vertically and horizontally or not? We want it vertical, horizontal, vertical, horizontal. So those are the things. Now for the soil chemical properties, there are so many, pH, nutrient, organic matter, whatever. This thing must be in good synergy for us to talk about the soil quality. And the microbes, like we just heard about the biodiversity, these are the things that they were trying to talk about. These are the things that we don't have a choice, but we have to go through. So the last part of my talk will be the plant health. I'm just going to run them through. I'm not going to talk about them. Much as we want to see the soil health, the animal health, the plant also must have this kind of health. And we have about almost 10 indicators. So one thing that maybe as a new entrant or whatever, the crop appearance, once you master this, is going to help you a lot. So here we are talking about disease symptoms. We should be able to know these kind of disease symptoms. And then we are also talking about crop growth. How do you know that your crop is growing very well? So these are some of the things that you need to think about. We are also talking about tolerance. Just now I told you that we use silica to maintain the resistance of the soil, of the crop. So when you are managing your soil, you should incorporate activities that will boost the tolerance of your soil, just like human beings to boost your immunity. So those are some of the things that I'm trying to show here. And then we also have to look into disease and pest incidents. Again, how you manage your soil, if you are using biological approach, chemical control or whatever, how will you replace chemical control? How will you manage your soil that the soil is become less disease, or what do you call it, breeding ground or whatever? So those are some of the things that I think I can share with you. And then we are talking about weed competition. Weed can be very, very obnoxious. So we will have to look at it because you don't want your money to be competing with weeds. So we will have to know, how do you manage your soil? Especially, are you doing multiple cropping? Are you maintaining the quality of the soil so that you don't grow a lot of weed seeds in your soil or not? So these are some of the things. And then we have number 6 to be the potential yield. Always try to go for the optimum yield so that you don't lose your potential. So these are why I took my time to show optimization of whatever. Genetic diversity is very important because you see, climate is changing and we are having a lot of challenges. So this is where climate smart type of agriculture will work hand in hand with what we call genetic diversity. And then we will also look into plant density. The carrying capacity of the soil is very important. When the soil is too dense, I mean the plant is too dense, you have problem with photosynthesis and the like. And then the last part, I think, will be the natural surrounding vegetation. If you are a good agriculturist, you also have to care about your neighborhood. Because remember, example, if you are growing rice, you don't care about your neighborhood. Remember, even I mean, what do you call it? Birds and whatever can come and destroy you. So here, much as you want your farm to be clean, the surrounding must also be clean. And then the last part, then I end my talk, will be your management system. How do you manage the soil? How do you manage the environment? How do you get your optimum output? So these are some of the things that I think that we will have to go into. How do you avoid chemical fertilizers, pesticides, and whatever that will harm the environment? So my take-home message will be, with strong institutional structures, which I implore all African governments to be sincere and then try as much as possible to put the country first and not the individual gains or political gains, then it is possible for the African youth to also excel by optimizing the resources through modern agriculture so as to ensure that we have sustainable growth and development in one avenue called agriculture. Our resources, our natural resources or whatever have become just like a curse or I don't know, it's not helping. So I think these are some of the things that I think the youth, I will implore you to look into it seriously if you want our future to be guaranteed. Maybe we might not see it in our lifetime, but it is going to be your time. Be proud of your continent and let people also feel like they want to visit Africa with some positive mind. Nobody, don't blame anybody for them to look at the perspective from a negative way. It is up to us to reverse the situation. Thank you very much, Dr. Mutakar, and my respected audience. Thank you very much for your rapt attention. And I'm sorry for taking that much time. I just feel like I have to share and then we see how we solve the problem. Thank you very much. Back to the chair.
Wow, thank you so much, Prof. Very informative, insightful. Without any delay, we'll open the session for Q&A. And for those of you who have been asking for the slide, we will share the materials later together with your set. Just drop your name and email in the chat box. I'll revert to you. Okay, the floor is open. If you have any question or comment, then please, you may unmute yourself. Allow participant. Okay. Any question? Any question?
Please feel free, feel free.
If you cannot, you may type. Can we have physical conference? Somebody is asking, can we have physical conferences in the future? Hopefully after COVID.
I think.
Okay. Gideon, Gideon, you can go on.
Is it a question addressed to me?
Yeah, it's just a general question. That can we have a physical conference or in the future?
Sure, we will prefer that so that we can have more interaction and then we can share more ideas. We look forward to that. Together with my team, I think we will thank you for that. And again, sorry, I would like to thank my team. Most of them are around. So if there's anything, they can also chip in. Thank you very much. I'm looking at the chat box, but I don't see any questions so far.
Okay, you may raise your hand, then I'll ask you to unmute. I think Ali Sise Garba, you can unmute and then talk.
Hello?
Okay. Yeah, you're on.
This Mutalib here, Prof.
Yes.
Thank you thank you for the presentation. Some of us, we are not in the agricultural area, but we are interested in diversifying into the agri sector. How can we get more assistance from you? Probably going back home, like I have maybe like a 10 acre of land. But I don't have idea of the type of the soil, just the way you explain now. So how can we get more help from you?
I mean, you could always contact me. I think not only me, with my team. Our details are with the organizers, but we can help you by advising you. But it will also be quite essential that if you are back home, I'm not sure of your country, but if let's say you are in Nigeria, I think you also have Nigeria. To liaise with yes. You also, I think you have extension officers, you have some of the universities around, you have your research institutions. I think they should be able to also help you. But if you want us to transfer what we have now, for sure, we are open for this. We are really open, and you can get in touch with us and we can start it from there. Thank you very much.
Okay, sir. Thank you.
Okay. Ali Sise. Gideon, Mr. Gideon. Okay, Ali Sise, you're on. Okay.
Once again to you for President Lekim. We there are a lot of things that Prof has really mentioned, which maybe we cannot capture it now.
Please, is it okay? You become audible. Your voice is wobbling. I'm not hearing much.
Hello, can you hear me now?
Yes, please.
Yeah, what I'm saying is Prof has touched on so many areas that we're interested in. Currently, we're working on a project on how do you call it, onion plantations in Ghana as a result of importing a lot of onions from.
Honestly, I can't hear much. I can't hear much. I can't hear much.
I have a problem with my mic. Maybe I will send an email. Maybe subsequently we'll have a discussion.
Yeah, because I'm afraid if I don't get your question well, I might not be able to answer you well. I'm really not getting it. But if you can type it, it's all right.
The mail.
Hello?
Hello? Hello, can you hear me?
Yeah, now it's clear. But
Hello? Hello?
Yes, we can hear you.
Hello? Oh, okay. I was thinking, I wanted to ask on can we use the hydroponic method for onion production?
Oh yeah, it's a vegetable. Why not? It depends on the way you look at it, because onion it roots, right? I mean, it's more like a tuber type of whatever. So it depends on the way you do it. But if I were you, if you want to go hydroponics, that would be fine. But I would rather ask that if you want to go more to fertigation, would rather be more useful.
Okay, and the climate doesn't matter, because as you can see, the climate over here in Ghana, I don't know whether it's very good for the onion production, because most of our plantations are in Nigeria and Niger.
Oh, as far as I'm concerned, onion is grown in Ghana. Definitely, you can grow onion in Ghana. Definitely, just that it depends. If let's say you want to make it in a greenhouse, then you will have to control the humidity and the temperature.
Okay, and all the varieties can be done, because yes, the onions we have in Ghana are very small ones, like
yes,
those ones that's coming from the neighboring country.
Yes, it is. You can any class of onion can be grown.
Okay, thank you very much, and maybe you have some other.
Right. Thank you. You are most welcome.
There's a question in the chat box.
Okay, somebody is asking that, can I explain a little bit of cloud farming? Cloud farming here, we are not talking about the cloud in the where you are growing and then you have to follow the cloud. Then from there you can predict. The cloud is mean that you have accumulated before we, let's say, like cloud can be an information more or less like a database. That is in the example, a platform called Google Cloud platform or something like that. Or we have individuals who create their own, clouds. So here, what we are saying is that they normally a government can team up with such situation or come out with, if we have the technology, they can, let's say, like zone by zone, they can accumulate information in terms of climate, information in terms of soil type, information in terms of crop type, information in terms of disease infestation or whatever. So all these information will be kept in a database and it will be processed. So once you process it, you will get this kind of information. If it's for rice, you need this, maybe you have to plant around this time, and then you need to apply your nutrient around this time, or you need to, it can trigger you are likely to have some water deficient, and then these are all communicating with your cloud information. Then from there you do mitigation. So it is more or less like it's a database, and like the way you have your database and you use your database, but this is real time and it's only already in the cloud system technology. So that's why we call it. So that kind of information that is helping you to be smart in the cloud, that is what we call cloud farming. We are not talking about literally the cloud that you see, if that is what you want to know. And then somebody is saying that how do we have the wonderful things incorporated into government policies, especially in Ghana? Well, I don't think this is anything extraordinary. It is just the will of the government to mobilize those who know, the technocrats, the professionals. So it's just like now, you open up and you access to come and talk. We talk with your agencies, example. We sit down, we map up the situation, and then there we go. So the policies are just as to tell you, the government, and it's up to them to take it over. So here, it is about connection. How do we relate? So somebody must create that kind of platform. So once we get into that kind of platform, then we should be able to get into that system. So here, there must be an initiative in the intermediary. I don't know how to go through. This is why our high commission should be quite effective in these kind of things, so that we in the diaspora can link up with those back home, and we see how we take the thing to the next level. So that is my answer to your question. It is just a matter of we have to have the link being established. How we do it, I'm not really sure, but I think for me, we can go through our high commissions, or we can have an intellectual forum, like they are saying, open conferences and whatever, symposia and whatever, roadshow, exhibitions. Then we table our case, and then we sit down and we have a policy formulated, and it becomes a national agenda. Thank you very much.
Any other question or comment?
Hello, can I come in?
Yes.
Yeah, my name is Fuad from Accra, Ghana. Thank you so much for this insightful engagement. My first question is to the organizers, whether there are plans to regularize such interactions in the near future. The second one just follows up from where Prof ended as to what will be the initiative to have such wealth of expertise being placed at in our policy decision. I will request for maybe from the organizers an email address of Prof. Then I work within the cocoa sector, but I do a lot of other private initiatives in other agribusiness sectors. Yes, is it clear?
Yes, please, I can hear you clearly. Please go ahead.
Okay, as the last part, as I said, is to get an email address of Prof.
It's possible. Organizers will get it to you, and then we are willing to communicate right away. Hello?
Please, you are muted. Unmute yourself and come back again. Mr. Fuad? Prof. Fuad still there? Okay, a moment, Prof. Fuad. Okay.
That's fine.
Okay, all right.
Yeah, I ended on request an answer for my first question. That's whether such engagements are going to be regularized by the organizers. I think we need more of such.
Okay, at the moment we do have just a monthly sessions.
Okay, that's really perfect.
Yeah, we started from June. Yeah.
I guess I joined it late.
But this is our first session on agriculture. The past sessions were on research, translating scientific information into scholarly publication.
Okay.
So this is our first series in agriculture sector. Yeah. Okay. So hopefully next month we'll still be alive, and then Prof will still have time to be able to share with us again. Okay. And then we are also open to any related topics that you want to suggest. Yeah, you can always communicate so that Prof will look at them at the appropriate time. We have sessions on. Thank you.
All right, thanks so much as well.
Any more questions? Prof, that's a question from Facebook. How can a farmer, a youth farmer in the village, become a smart farmer in simple ways?
Yes, I mean, this is what I just said. When we say a smart farmer, you must even be smart in your thinking. So here, if you, let's say it's in a village, I believe there will be schools. And this is where in the schools, we don't look at agriculture like, let's say example, you go to school and then the punishment you are given is to go and weed. That's the first point of punishment. So if you are in the village and then this is how you are being punished, how will you develop interest in agriculture? So this is what I'm saying. Even though they are farming in the village, they must be introduced and let them understand the value of agriculture. So I think in our syllabus, we have some sort of agriculture. So the teachers themselves must practice what they are teaching. So if you can do this, I don't think there should be a problem. But of course, when you are talking about satellite communication and whatever, that is fine. But in the village also, we can practice what we call, natural farming. So if already you are in the village and you have your waste and you can compost your waste, composting is very easy, or you can even recycle your waste in a way that you don't need fertilizer. This is what I'm talking about, agroforestry and whatever. So these are the basic things, because you see, the key thing about any soil is the organic matter. So once you have the organic matter in a form of recycling, just like the way that we used to grow cocoa back home, where those days, the cocoa leaves will fall on the ground and they decompose. So if you can do these basic things, definitely you can go to small kind of farming. But to go into the satellite communication, that is the role of the government. So ordinary kind of natural farming in the village is still there, but just that our extension officers must penetrate and go down and teach them the right thing to do, the basic thing. Example like pH. pH, let's say, where are you going to get pH meter in a rural area, assuming you don't have electricity? So you don't talk about digital pH. So you will have a kit where you take the soil or whatever, dissolve the soil in the kit, and you just show it to the villager and say that, you see, this problem is like, it has this problem and this is what we do. If it's acidic, add organic matter, it will detoxify. So I think the basic things like kits, basic teaching, what is a soil texture, what is organic matter, if your soil is acidic, how does it look like, what is doing the color to show that a soil is potential to be a good agricultural land. So these basic things must be there, and the only way to do this is to teach them right from the beginning, and the nation must be serious about agriculture. I do remember when I was in the university, when you go for agriculture, the family thinks like, why are you going to agriculture when there are others? Your grandparents and your mothers are growing. And so basically, yes, go down to the bottom and then let them be taught right from the beginning. Thank you very much.
Afolabi Precious, you raise your hand. You want to say something? If not, we take 2 questions on Facebook. The first question, Prof. That I hope you will come to Ghana and we farm together. And then number 2, which type of rock do we grind and apply for our crops? So these are the 2 questions from the Facebook.
The first one, when to come to Ghana, I think.
And farm together.
Yes, we will go. That one, I think once a while we go to Ghana anyway. The second question is what? Dr. Mutaka.
Yeah, the second question, that which type of rock do we grind and apply for our crops?
Oh, okay. I think you may use rock, right? It's talking about rock.
Yes, Prof. Yes.
Yes, you can use rock phosphate, but this rock phosphate is just like crude. I mean, it's just like crude oil. You know, it depends on the country. They are specialized type of rocks. So that rock in West Africa is found in Togo. We call it Togo rock phosphate. So that kind of rock is the one that you can grind, and once you grind it, you will have more of phosphorus, and then you will have more of calcium. So that is what I can recommend. And because we don't have volcanic eruptions in this kind of region, you might not have zeolite in that place, and therefore rock phosphate could be one of them. And if you have calcium carbonate rocks, then we can also grind them. They can serve as a source of calcium and a source of lime. Gypsum is also another type of a mineral. We can also grind them. So when you go to your university, you go to soil science department or geology, and then tell them whether they have gypsum, rock phosphate, you are talking about dolomite, and you are talking about calcium carbonate. These are some of the things that you can break down and then apply. But things like zeolite and whatever, they are very specialized. It depends on the country that you are in. Thank you very much.
Okay, Polabi, please unmute yourself.
Hello.
Professor. Hello.
Okay.
Magaswa from International Islamic University. Thank you, Doctor, for your brief explanation. I really appreciate it. My first question is now in Africa, we are showing the seed, for example, the seed of rice or cotton is coming from a laboratory and made by one of the French company to give to our cotton culture or our seed. Is it sustainable, or what is the great impact of that kind of seed in cotton culture or our rice culture for the soil?
Dr. Mutaka, can you rephrase the sentence, because some part I couldn't hear very well.
Yeah, actually, I could not hear him too. His line, I'm not sure. Yeah, his line wasn't clear. Can you come again? While waiting for him, there is a question here, Prof, in the chat box. Good day, Professor. As far as I know, the organic amendments can be produced using composting technique, ashing, and many other methods. What are the examples of organic materials that are suitable to be used for composting? And what are the examples of organic materials that are suitable for ashing? Thank you.
All right. If you are talking about composting, first, the assumption is any organic material that has carbon, a little bit of nitrogen, should be able to decompose. So whether you talk about rice straw, you talk about oil palm materials, you are talking about vegetables, any type of crop. The key thing is, one, the CN ratio, the lignin content of the material is what is important, the lignin, because that is the hardest part to degrade. That is number one. So the initial CN ratio is what is important. The next part will be how you do your composting. How do you maintain the moisture? How do you maintain your temperature? And how do you allow your microbes to degrade your material? So any organic material, any plant material, any animal material, so long as the CN ratio is not too high, sometimes if the CN ratio is more than 200, definitely it's going to be, it can be degraded, but it may take about 3 or 4 months. So my answer to you is any material that can be degraded by any organic microbes can be okay. Now, in the first place, we don't ash compost. Ashing has something to do with burning. So once you do the burning, that means that you have already lost your carbon. So that product is never called a compost. So when you talk about ashing, it's another way of trying to change the organic material into inorganic, because the ash contains only cations, calcium, magnesium, nitrogen is gone, phosphorus is gone. So if you are talking about ashing, it depends on what you want. If you ash, what kind of elements are you looking for? Are you interested in high calcium, high potassium, high magnesium, high sodium, or not? If let's say, for instance, you are interested in high K, then definitely pineapple waste has a lot of K. Therefore, I would recommend pineapple. If, for instance, you are talking about, let's say, calcium, it depends on what type of plant are you talking about. For instance, if you talk about calcium, we can also equally talk about rice straw. In this country, they have something called sago. Sago is very high in calcium, so you can go for sago if you want the ash to be. So it depends on your interest. So that is what I can say. Composting, the first thing you should look at the CN ratio, and the next one is the technique that you use. That's all. Thank you very much. Any organic material should be able to be decomposed. Thank you.
So, Prof, there's one question. Hi, I'm from Afghanistan, IT student in Moscow. I'm working on a project to design AI app, AI application to detect disease. But the main part is how to find and manage loss of plant diseases. Can we have your contact?
How to manage loss?
How to manage, I think, lots of plant diseases could, or lots plant diseases.
A lot of plant diseases.
Yeah, can we have your contact information set to help? Okay.
Okay, I think that's why I talk about the infrared zone. You see, the idea of the infrared to near infrared is when the light is scattered from the atmosphere, some of them get deflected. And the visible range that you see, ultraviolet, the visible, and then you have the near red. I think he will understand because he's in this area. So you have the infrared, and then within the infrared, we have the band. I think the band is around 400 to 800 or 900 or something like that.
Yeah,
so those are the ones, sorry?
Yeah, he said he's an IT student. He wished to get your contact for further discussion if permitted.
Okay. In that case, okay, he can get my contact then.
Okay.
All right. But I think the basic thing is he has to work around the near infrared. So when you get the near infrared, this is a light source, and it can penetrate so many objects. So when it penetrates, we have what we call absorption, then transmittance and reflectance. So how much you absorb and how much you reflect will tell us. And because there's a bond arrangement that will be distorted. So let's say, example, if it's, let's say, like, if it's maybe like if it's a fungal attack, so what it is going to remit will be a certain band. Then you have to capture the band. Then you can match it with the fungal characteristics. Or what example, when let's say you are talking about, let's say like a disease, maybe like let's say nematode. So that also will absorb certain energy and reflect certain energy. So once you absorb the energy, then you can find it in a form of image. So this is what we call imaging technology. So the colors will come out, or you can use the quantity to draw your colors. Then from the colors, you look at standard, and then from there you will know. So I think let him contact me later.
Now, Doctor, can I come in?
Yes, please, Royce.
Okay. Yes. Now, Prof, thank you very much. This is Siraj, Ghana and UPM.
Okay.
Yeah, Prof. Please, you talked about ITER. You know, that's our field and our area.
Very
And
good.
we feel like trying to also contribute to Agric because it's a wonderful field. So my simple question is, what are some of the areas you think requires some kind of attention and from the area of IT, collaborating with Agric scientists?
Okay.
Yeah, thank you.
To be very honest with you, I may be a little bit biased here. From my basic understanding, a lot of information has been known about the crop. A lot of IT tools or whatever, instantaneous measurements and whatever. But until today, I have to let you understand that in the soil, we really don't have much real-time kind of information. Example, now they talk about all these sensors and all whatever. All that most of them can do will be pH, moisture, and then maybe nitrogen, and then maybe EC, and then maybe organic matter. But when we go down and we say we need an information to tell it the soil structure, how it should look like, the soil texture, and then we are talking about even the detailed aspect in terms of, let's say, like the humic substances and whatever. Those aspects are never there. So for me, if you ask me, if you can come out with a technology that can penetrate the soil to 1 meter depth, and it can even help us to quantify the carbon distribution within 1 meter, it can help us to participate in the carbon credit, carbon footprint. If you, let's say like now, we are going to have a project and we have to go conventional. We have to do destructive sampling, or we have to use model to just do estimation. And we have to take the soil sample layer by layer. We bring them to the lab, we analyze the carbon, then we have to do some calculations and then per hectare. So if you have the IT where we can beam a laser and it can tell us layer by layer, this is the quantity of carbon, this is the quantity, that would be very fantastic for us. And we don't have these kind of things. So if you can go into these things, I think you can help us in the carbon credit issue. And it's a very important area, carbon sequestration. Thank you, sir.
Okay, Prof, from the Facebook, can you explain again on the oil palm fertilizer application?
I don't know where to start. It's a broad area, but what I was trying to say is when you are dealing with oil palm, I'm only talking about the soil and the fertilizer aspect. The first thing that you should understand will be the root architecture. The root architecture is very important because oil palm is a very heavy feeder on nutrients. And normally the root architecture determines how you fertilize and how efficient you are going to be, even in terms of liming. So if you look at the root, when you move horizontally, it moves up to what we call 4 meters. And the canopies must be proportional to the 4 meters on your left and your right. So now let's say you decided to apply your fertilizer 1 meter, especially when the oil palm is young, 1 meter from the plant. What you are assuming is the fertilizer there will diffuse. And as the root is extending from, let's say, 1 meter to 2 meters, 3 meters, your assumption is that the fertilizer is moving to the root hairs. Remember, where you have around the 4 meters or 3 meters, you have what you call the rhizosphere. Rhizosphere means the root hairs. It's not the taproot, the root hairs, the small roots around the main roots. That area is what the nutrients are being taken up. So when you apply it around 1 meter and now the root is getting to 3 meters, that means that you are not tracing the movement of the root with respect to the fertilizer. So this is where you see sometimes you apply a lot of fertilizer and yes, you see deficiencies. This is just one aspect. Now, the other aspect will be also the nature of the soil. If the soil is acidic, the roots cannot extend that way because the root hair will die out of acidity. So here, the fertilizer that you are applying, if it doesn't diffuse, there's nothing that's going to go. So here, my advice to you is if you are talking about fertilizers, then you need to understand the root architecture. Now, once you understand it also, you have to know what type of fertilizer you have to apply. Because in the oil palm, let's say if you apply nitrogen, P and K, yes, you can apply in terms of quantity. But another aspect that the fertilizer, I mean the oil palm is very sensitive to is copper, zinc, and boron. And normally these fertilizers, they are just little, very, very small. Sometimes let's say like 200 grams, 100 grams. So what do if you don't apply it? So here, some people are talking about trunk injection. Others are talking about foliar application. Some are talking about frequency. So this is what I was trying to say. You need to understand the soil, and then you need to understand the movement of the roots of the oil palm. Otherwise, your fertilization must be very, very non-uniform. This is why when you come to this country, they have what we call the palm front. I mean the palm circle, about the circle around the palm. That's where they fertilize the fertilizer, and they try to match it with the rooting system. And again, it depends whether the soil is a mineral soil or is an organic soil. Organic soil means that it's a peat soil example. If it's an organic soil, the rate at which the nutrient will be leached is very fast. So you have to know whether you are using a slow release type of fertilizer. Otherwise, if you use fast release, you are going to lose it. And in organic soils, you also have to manage the water table. If you don't manage the water table also, there is going to be a problem. So it depends on the situation. But I do know if you are from West Africa, I'm not sure if that's where you are from, we don't have peat soils. So it's more going to be your mineral soils. Thank you very much. Hello, Dr. Mutika.
Yeah, okay, thank you, my progress. Another question. I am sorry for asking this again as it is not answered yet. Oh, okay, sorry, Roshi. Prof, it is true that organic farming gives a lot of benefits to both soil and crop. By most of the plantations, chemical fertilizer usually is used instead of organic due to the cost aspect. How can we encounter this problem?
Yes, you are right. In fact, organic fertilizers could be very difficult to use 100% in plantations. Or maybe they are very effective for perennial, annual crops or whatever. This is why I did talk about biological farming. Biological farming is you have no choice. Not only you are using your organic system, the biological system, but you have no choice, like oil palm, or you are talking about mango, and you are talking about tree crops. So here, if you go organic completely, maybe there could be deficiencies that could not be corrected. So this is where we are saying that you can still use a chemical fertilizer, but instead of, let's say, using 100%, and the organic amendment is able to make even the chemical fertilizer that you are using become efficient so that you don't get much losses, then in that case, you don't have a choice. You go for chemical, but you have to supplement with organic so that your soil system will be better and be efficient. Some of the work that I show you actually is not 100% organic. It's both chemical and organic. But what we do is we only apply when necessary. This is why some of them we can eliminate 60%. Some of them we can eliminate 80%. Some of them we don't have a choice. We can only eliminate 40%. So this is what we call biological farming. So your approach should rather be biological farming, organic plus chemical. But the chemical also, you need to know what kind of chemical. If you are using a chemical fertilizer, do you have a lot of cadmium inside? Do you have a lot of arsenic inside? Nickel. We have to know the threshold. Then that will be fine. So that is what I mean. Not every crop you can go 100%. Otherwise, you go bankrupt. That's why even in vegetables, you are talking about the annuals. You also have to target high value crops. Those are some of the things. Thank you very much. But when your soil is highly degraded, you don't have a choice. For the first few years, you need a lot of organic input to rejuvenate the soil. Thank you very much.
Okay, thank you very much, Prof. A question almost overlooked. This one, as regards to food waste, what can a farmer do in a country which has little or no technology to support preservation? Again, can there be an intensive training on digital farming? Thank you.
I think I get what you are saying. If it's just like the waste that you can recycle and then produce your organic fertilizer, oh, that is fine. But let's say you have harvested, now you are talking about post-harvest losses and all sorts of things. I think this is beyond me. This is where the government has to come in. You got what I'm saying? The government has to come in and have what we call purchasing centers, just like those days what you need to do in cocoa marketing boards, where to every corner you have cocoa buying, a shell and whatever. So these are some of the things. If it's going to be perishable, then do we have the vents that can move the product right from the farm gate? Or do we have holding places? So I think these are some of the things that the African governments must spend some time and be very honest and then help. If they really want to boost agriculture, you must go right to the interior and provide them with what they can. It's not only this kind of post-harvest losses and whatever. Sometimes also, even you are ready, you don't have good roads. When the roads are not there, you even harvest today, you want to send it to the market. Now they have the holding centers, and assuming that it's going to take 1 week or whatever to move away from where you are. Now you are not being, your value is going down. And so these are some of the things that is a national policy. So it is beyond me to answer that this is what you need to do. But if you don't have a choice and you want to recycle, the only thing is to turn it into organic fertilizer and then you recycle. But that is not the option. Nobody goes to produce and recycle just like that to throw away your money. So this must be a government will. All these talk that I'm talking about, if the government or the right institutions do not come in, it becomes just an academic exercise. So those of you who can actually influence policies, we are on our knees for you to do the honorable thing by looking into policies that are in the best interest of the nation. So that is what I will say. Your extension officers must play their role. The agricultural agencies must play their role. Ministry of Agriculture must play their role in relation to other agencies. Thank you very much.
Okay. Thank you very much, Prof. Any other question or comment? Okay, I think, Prof, maybe there are no questions, and I believe we have talked a lot. Perhaps a closing, perhaps thoughts, 1 or 2 sentences, Prof.
All right, thank you very much. Again, I would like to thank you and the organizers. It's more or less like a privilege to be with you, to share the little that we have.
Okay, sorry to interrupt, Prof. Sorry to interrupt. Someone has sent a last minute and last one question.
Okay,
now,
don't worry.
Okay, now what is your idea, sir? What will be the new challenges in agriculture in the near future?
For me, the serious challenge, as far as I do know, will be soil degradation. So just imagine for FAO to designate last year to just talk about soil degradation, then that is a big thing, especially in the areas where we have natural resources. And you all know, when you have a place with diamond, you have a place with gold, you have a place with other things. So the fundamental thing is the soil erosion. That is the issue now, because we are running out of arable land. No matter what we do, the climate is there, but the soil is another issue. So if you go to the international world, this is what I see when I just told you just the sustainable development goals, where we have 17 of them and 12 of them are based on soil. Then you can imagine the issue. So for me, soil erosion is the issue. Thank you very much.
Okay. Who else? Who is this one? Oh. I don't want Prof to go. Okay, this one, thanks. Okay. All right, Prof, then can wrap up. Mhm.
Okay, like I said, thank you very much, Dr. Mutaka and your group for organizing this international meeting. I understand that it cut across, so I thank all of you for your coming. And then I hope that we'll meet again. And it's not just a talk, we walk the talk. And definitely, I would also like to thank my team members. All the things that I said here, actually, I never did them alone. We have the number of them that I think I need to acknowledge. I'm not sure whether they are here. We have Dr. Latifa here. We have Dr. Hack. I'm not sure whether Dr. Palani is here. We have Lisa is here. Dr. Adiza Alasa Musa is here. We have John is here, Priska. And then we have Hidayah. We have Warda. And then we have who else? If I've missed out your name, Kevin, you are here. And then the two Kevins, you are all here. So anyone that have left your name, thank you very much for your kind support. And we appreciate it. Without you, this knowledge will not be disseminated. And then thank you, Dr. Muntaka.
Okay. Thank you so much, Prof. Inshallah, we hope to have more sessions with you. And to all the attendees, participants, commentators, we thank you all for being with us today. And then to Prof and
I'm
the
sorry,
team.
I think there's someone I didn't acknowledge is Dr. Aina. Dr. Aina also is here that I forgot to acknowledge, and anyone else. Thank you very much.
Okay, all right. So the team, once again from here, Prof and the team, we thank you so much. And then may Allah reward you. We cannot pay you. You are doing a free service to us. We hope in your needs, in your wants, we pray that Allah bless you and satisfy all your needs here and here. Okay. Thank you so much. And we've come to the end of our session today. So we'll see you again, inshallah, next month. Say bye-bye.
Okay, bye. I forgot one of the team members called Alicia. I think she's also here. So thank you very much, Alicia, for coming. All right. So may I leave if you don't mind?
Yes, please, bro.
Okay. Thank you very much.
Yeah, and gentle reminder, if you have not dropped your email and your name, kindly do so for your certificate, presentation material, and then also the video recording. Thank you.
Again, another one, Puven. Puven is also here. Just remember, sorry. Thank you,
okay.
All right.
Okay.
I have to satisfy everyone, sorry.
Yeah, big thanks to all the team members. We don't know them. We hope to see them sometime again. Okay. All right. Thank you.